Good afternoon, everyone, or good evening, or good morning, depending on where you're tuning in from. It's my pleasure to welcome all of you to this first online symposium on research integrity in the Netherlands here. This is the first time we're doing such a thing entirely online. It's also the first time for me moderating such an event, so bear with me a little bit, maybe. I would like you all to know that there is also an upside to the fact that we're doing this entire thing online, which is the fact that we have a lot of participants, probably more than we would have had if we had all been here in the Pakhuis together. Yesterday we had over 650 registrants, which is very exciting because we want this symposium to be something that is relevant for everyone across the Netherlands, even abroad, and also across all disciplines. So welcome again to all of you here. I would like you all to know that we will have someone who will be moderating the online audience. So I'm going to hand it over because we're obviously not going to be able to fit everyone on your screen with such a large audience. So I'm going to be handing it over to Fenneke Blom, who will be moderating the online audience. Fenneke.
Thank you, Jeroen. My name is Fenneke, and as Jeroen mentioned, I'm your online moderator today. So I'll be interacting with you in the chat, and I will be going through all your questions for speakers and passing them on to Jeroen. Important to know is that you have in your tools two different sections. There's the Q&A and there's the chat. All your questions for speakers, please post them in the Q&A. And you can also upvote questions of someone else who has a similar question, and that increases the chance that we will get to your question. And all the other things that you would like to share with other participants, you can use the chat for that. So please don't post your questions for speakers in the chat, but use the Q&A section for that. Thank you. I will be going to my computer now and will be interacting with you. Looking forward to it.
All right, thanks so much, Fenneke, and thanks for taking care of this. So our topic today is research integrity, and I want to share a little bit with you about why this is something that is actually very dear to me. I'm a philosopher of science myself, and currently also the president of the Netherlands Young Academy. So it's part of my job description, you might say, to think about how we can do science well and how we can improve science. And I think we're living through a momentously important time in this period here. I mean, it's pretty obvious to everyone that we depend on science to deal with this pandemic. But it's also pretty clear to a lot of people that there have been issues with integrity in science. So I feel like today and in sort of the period leading up to this, there's a real opportunity for us, the academic community, to rise to the occasion and to really address questions about how we can do science better. And it is in this spirit that we're having this symposium today, to think about how we can do science better. And it is also in this spirit that today we're launching the National Survey on Research Integrity, which is the largest ever survey on this topic. So we're not only going to talk about research integrity today, we're also going to take action, because everyone will be able to fill out this survey starting today. So a very exciting time. Let's talk about our program today. So we have a total of 8 speakers. During the first half of the symposium, you'll hear 5 speakers, and they'll all be addressing issues having to do with research integrity from a variety of angles. There'll be a Q&A after each speaker, of course. Then we'll take a short break, and then after the break we have 2 more speakers, followed by a panel discussion. And then finally, at the end of our event, we will be launching the national survey that I just mentioned. So please stick around until the end, because really the best thing is going to happen at the end of the symposium. So not a lot of housekeeping, since you're all online anyway, so in the comfort of your own home. One thing, if you're active on Twitter, please use our hashtag NSRI 2020. So if you want to join the conversation on Twitter, please make sure you use that hashtag. So without any further ado, I want to get started and introduce to you our first keynote speaker, Klaas Sijtsma. He is currently the rector of Tilburg University. He's a professor of research methodology, of psychology, and he has dealt with a number of pretty serious integrity cases. So it's a real honor and a pleasure to have him here today at our symposium. If there's anyone who can talk to us about how you deal with research integrity at an institutional level, it is Klaas Sijtsma. So Klaas, The screen is yours.
Thank you very much, Jeroen. I'll first try to share the screen with everyone. Is this okay? Okay, well, I suppose you can hear me and also can watch the screen and follow my slides. Hello, everybody, wherever you are. I can't see you. You could be in outer space. As far as I'm concerned, I don't know. I wouldn't know, but I know you're there somewhere. Let's have a look at what universities can do to foster responsible research practices. But before I get to that, a little bit about statistics, because that is my field. I will concentrate this talk on questionable research practices and responsible research practices, the opposite of them. I will not talk about fabrication, falsification, and plagiarism. And this is what the moderator actually was referring to. So I won't talk about that. It's very serious business, but I hope rather rare. Bad for our reputation, but because it's rare, I'd rather concentrate on questionable and responsible research practices. Stenek put three kinds of activities on a continuum. On the left-hand side, we have responsible research practices, which follow textbook behavior. You could say it's perfect research behavior. And some of us master that. Many of us are normal people and we don't master it perfectly. And then we run the risk of getting involved in questionable research practices. So that refers to real-world behavior, which is often fallible behavior. And there's, I would say, nothing wrong with it as long as you're prepared to correct those practices. And I will skip misconduct. So what are questionable research practices? Here is a list I took from quite a famous article from 2012. I picked out three examples. If a test is non-significant, which is one, collect more data. This is often done in an experimental setting. Perform the statistical test once more. If it's non-significant, repeat the procedure and continue until you have a significant result. Well, you can actually mathematically prove that if the null hypothesis is true, this procedure with 100% certainty leads to the rejection of the null hypothesis, which means that you have a completely useless result. Another example is the reporting of only results favoring one's hypothesis, meaning that you leave out results that don't favor your hypothesis. So you're a little bit too selective here. And the final example I want to pick out is to present unexpected results as if they were expected. You may think of a correlation matrix based on many variables, so a huge matrix in which always one or two interesting correlations pop up, but they're only interesting after the fact. You didn't expect them. But sometimes people, you see in this survey, in 27% of the cases that were investigated, 27% actually admitted that they presented results like this. Okay, I want to talk about three topics. The first is the most likely causes of errors researchers make when designing research, analyzing data, and interpreting results from data analysis. Second, why research policy helps more effectively to encourage responsible research practices than improved methodological and statistical methods, and this coming from a statistician. And third, how Tilburg University implements policy to encourage responsible research practices and prevent questionable research practices. Okay, what are the causes of errors? Where do errors in the use of statistics come from? Well, here is the explanation. Researchers, you may think of biologists, psychologists, economists, need to use methodology and statistics for their data analysis, but they are experts in another field. They are experts in biology, psychology, or economics, but not in statistics. It's not their profession. So in other words, they practice methodology and statistics on the side. Now, statistics is difficult, and the results are very often counterintuitive. One is actually constantly misled by statistical results. Now, if you add these facts to a climate of performance pressure in which we all find ourselves, we have a toxic mixture called questionable research practices. I would say it's unavoidable that this happens, and it actually has happened. Why is statistics difficult? Tversky and Kahneman, two very famous researchers in the 1970s, already explained this. They showed that statistical reasoning requires rational and conscious reasoning. And that costs an awful lot of effort. Our brains are not very well designed to do that. People simply don't do this. Their first inclination is to follow their intuition and jump to conclusions. You might say, this is how we struggle and model through life, also when we do research. Now, intuition works in two different ways. You have intuition based on experience, and this is the kind of intuition that makes you do approximately the right things, even before you have started thinking about a well-founded answer. This is what experience does. The other kind of intuition is based on heuristics, and it makes you respond using cognitive automatisms that replace the difficult but correct question which you find impossible to answer with the question that looks like it and is easier, but of course is incorrect, so the answer doesn't make sense. It puts you on the wrong track because this is usually what you're inclined to do. And the third reaction is cognitively demanding. Try to solve the problem rationally, but this is not what we do first. We rather react intuitively. Here's an example of a difficult question. It's a famous one, actually, and you'll find it in the literature on probability and statistics in many different versions. Now, imagine Saturday's edition of the newspaper, and suppose it's 1 centimeter thick. I think that's rather realistic. Now, fold it once, fold it twice, again. When is the pack of paper thick enough to reach from here to the moon? Well, the intuitive, experienced response is, something's going on, be careful. It puts you on guard. Don't answer right away, take your time. The intuitive heuristic response, however, is to replace this question with an easier one that looks like it. And this is what we do automatically without thinking. Something like, what's the distance to the moon? And the answer to that question is simple. It's huge. You don't have to know it precisely, it's simply huge. So folding must take forever. And finally, the rational response is the demanding response, and it involves solving the problem. Nobody does this when asked a question like this. Here's the solution, and it's probably surprising to many of you. 35 times is too little. You are 100 kilometers, you end up 100,000 kilometers on this side of the moon. 36 times is too much, you'll end up 200,000 kilometers on the other side of the moon. You may notice the following things. You experience with this question an impossible task, and intuitively you move to a question that is different and gets you to the wrong answer, of course. And the nice things about problems like this is they make the point very clearly, because even if you see the answer, you don't have a clue what's going on usually. And so that very well illustrates the intuition that I'm referring to. Okay, what kinds of lessons do we learn from this? Well, we've been looking at a perfect example of exponential growth. And nowadays we have another example, a real life example on our hands, which is the increase of the number of COVID-19 contaminations. That's another example of exponential growth at a different pace. It's governed by the so-called R number, famous or notorious, whatever you like. It can speed up and slow down. It can even decline. It's very hard to understand it. I wonder how many people really understand this phenomenon. Other concepts from probability and statistics that are very difficult, but everybody talks about them, are probabilities. What's the probability of getting contaminated? Well, then we have to talk about whether we're talking about the probability of someone from a particular population, someone from a subgroup, defined, for example, by social economic status or age or a health group. Or are we talking about an event that takes place over time, and do we want to know the probability that it takes place in the long run? Another concept that people find very difficult to understand is the concept of chance, toeval in Dutch. If people would understand chance, they probably wouldn't participate in lotteries or enter casinos. And then the final one is I refer to numbers. If you ask people, no matter which people, to estimate the height of a building, you'll get the most amazing answers. And if you ask people what 1 million is, how much that is, again, you'll get the most amazing answers from almost everybody. Well, unfortunately, these very complex concepts and other concepts are central to statistical reasoning, so it's difficult. If you don't believe me, here are a few books I would strongly recommend. One by David Hand, The Improbability Principle, Why Coincidences, Miracles, and Rare Events Happen Every Day. It's a wonderful book. It helps you a lot, at least to understand why statistics is so difficult. And there's the other famous book by Daniel Kahneman, Thinking Fast and Slow. You must have seen it when you were on airports going to an international conference. It's everywhere. Fast thinking refers to intuition, slow thinking refers to rational reasoning. If statistics is difficult for everybody, does additional statistics education help to prevent questionable research practices? Well, statistics education shows researchers what's in the statistical toolbox and what they can use the tools for. So I think it's necessary to know these things. But you have to realize more education provides more methods or more details of methods, but no experience, and that's crucial. So what can statisticians do? Well, in addition to helping people to recognize the method that suits their problem, I would say teach people to recognize situations in which they need help. I think that is the crucial thing. You can't do everything yourself. You can be an expert biologist, a world-famous biologist, and not understand statistics fully simply because it's not your field. So ask for help if needed. What statisticians also should do is stop suggesting everybody can do statistics. I did that for years to my students. And I failed to see the fright in their eyes, the anxiety in their eyes. Statistics is really difficult. And be careful teaching crash courses, for example, in multi-level analysis, structural equation modeling, and so on and so on. It's simply not true that people go in as novices and come out as masters. They go in as novices and leave the course as novices. Okay, here are two pieces of advice before I go to the policy of our university. Make data publicly available. I would recommend that to everybody, each researcher. Let other people look across your shoulder and check what you do. Researchers are not used to doing that, so we have to help them. Here are a few suggestions, but I have to move on. And the second piece of advice is involve a methodologist or statistician in your data analysis. That is, hire the intuition based on experience that you don't have yourself. Again, if you don't believe me, here are a few sources that should make the point perhaps better than I can. Okay. Here's a disclaimer. Statisticians do not always provide good solutions. They are no saints, of course, and they may be too optimistic about statistics possibilities. But for example, Bayesian statistics is promoted a lot, has been promoted a lot recently, but Bayesian statistics by itself does not solve the problems that we're talking about, and neither do alternative significant values. Okay, let's have a short look at the implementation of policy at Tilburg University. You may remember the Stapel data fraud affair in 2011. It took place partly on our school and before that in Amsterdam and Groningen. So 3 universities were actually disadvantaged by this kind of, misconduct. It led the School of Social and Behavioral Sciences to install the so-called Science Committee. Well, what is it? What does it do and why? The Science Committee is an audit committee that samples articles from the school's database of last year and assesses the quality of the data storage and the reporting of research methods that are at the basis of the article that is being scrutinized. It advises researchers about their data storage, the completeness of their data sets, honoring subjects' privacy, access to data, and data availability. Its aims are to encourage a concerted effort to improve researchers' accountability for data handling and methods reporting. This is very important. People in the beginning were frightened of this committee, but it creates an opportunity for all to learn. It's not an organized witch hunt. We're not interested in that. We want everybody to have the opportunity to learn from what they do and are being advised from the committee and their fellow researchers. Okay, the Science Committee was installed in 2012. It started working as follows: set up rules and regulations for researchers' data handling. It announced annual random audits, and research groups were allowed to devise their own data storage policy that suited their needs best. So there was no general policy to begin with. We didn't want all the limitations that hindered these projects, so to speak. Simply start and learn on the fly. It works quite well, I have to say, but not perfectly, of course. Nothing works perfectly. Some groups had their data policy better in place than others. People tended to arrange their data storage only when they were audited, and of course, this is not what you want. When people left the school, they tended to lose commitment. Of course, you can't control this, but again, it's not what you want. And of course, there remains much work to do, but the great profit we realized was it creates a greater awareness, a stronger sense of responsibility and accountability. What about the general policy? Well, our university has a policy with respect to research and data management. And here's the state of the art. The other schools at our university did not yet install a science committee. I think it's a little frightening. But what they did is they all installed an ethics committee. And the ethics committees check in advance the compliance with research ethics and privacy regulations and data management. And the good news is it presents one counter for all these activities, and almost all researchers in our university comply. And this is very important for you to remember. There is no auditing in retrospect. What's not going very well at the moment is that most schools require their researchers to assemble a data package, which is okay, of course, but these data packages are all usually saved on servers of the university. And this is partly consistent with the VSNU integrity code, but not fully consistent. We also provide Dataverse as a universal system, which would be in line with the VSNU integrity code. But researchers seem to have cold feet for this system. Now, why do they have cold feet? I guess local storage feels safer, feels better, and Dataverse isn't local. Researchers, and we shouldn't underestimate this, are afraid they will be scooped, which means they are afraid that others will lay a hand on their data and publish interesting results based on their data that they might have published themselves. So they are afraid to be scooped. We have to find rules for that so that we can accommodate their fear. And researchers may not be the owner of the data they use, so they're not free to act. Okay, let's move on because I don't think I have a lot of time left. Okay, here's a summary. The summary is as follows. Our brains were designed for intuitive reasoning based on heuristics. Rational reasoning came later in evolution and is very difficult. Don't underestimate rational reasoning. Statisticians have experience, at least, so they have a tendency to postpone acting and are cautious. You may recognize this from consulting a statistician. What they usually do is they grow more and more silent the longer you talk, and at the end of the meeting, they'll tell you to come back in a week because they think it's difficult, it's a difficult problem, and they first have to think about this. Well, this is exactly what I mean. This is what you need, experience. Second, teach people, and this is to statisticians, teach people which methods are available and to recognize their weakness, people's weakness. That is, they have no experience usually, not all of them, of course. Some of you are excellent statisticians. But in general, if you're a great biologist, you're not a great statistician simply because you're not interested or the time is lacking. You don't have experience, only heuristics, so ask for help. Ask for help. I can't repeat this enough. And finally, questionable research practices are best fought not through more training and novel statistical methods, although from my own field I will say neither will hurt, but through policy. Publish your data, involve a statistician, and perhaps be audited to improve. Thank you very much. And if there are questions, I'd be happy to take them.
All right, thank you so much, Klaas. I appreciate your comment about statisticians having to think for a week and then coming back and telling you it's complicated. I thought it was only philosophers who did that, but apparently there's more of us. So to kick the discussion off, I wanted to ask you, can you say a little bit about how responsibilities for responsible conduct of research ought to be allocated? So I'm curious in particular to what extent you think the climate that we're all part of is conducive to individual researchers taking their individual responsibility in the way you described. So by involving statisticians, by taking enough time to address these issues. Is that something universities and departments provide for? Is it something the government needs to do more about? What are your thoughts?
Well, this is quite a difficult question. You know, what helped us tremendously, but I wouldn't recommend it, was the Stapel affair. So I wouldn't recommend anyone to have such a disaster in your school or in your university. But in the meantime, such similar disasters have happened elsewhere as well. Well, you can make use of a situation like that. You can use the moment to introduce a policy like this. People are very perceptive to it when something like this happens. I would also say in general, so don't wait for it. I mean, if you have to wait for it, you might wait forever, and that would be very good, by the way. But you shouldn't wait for it. I think it is extremely important that the administrators of a university, the executive board, the deans, the vice deans of research embrace this kind of policy and put a lot of work in it to have it accepted by the scientists, the researchers in our university. But don't underestimate those researchers themselves. Many of them already have embraced a kind of policy that looks like this. The awareness people have in these days of the need to be responsible, more responsible and more open about their research, the willingness to take steps, I think, is rather great and rather big. And so I think we're living in the right time to put a lot of effort into this and have it accepted on a broad scale.
All right, thank you. So there's a question from the audience, Bart Penders, and he's asking, can we understand you as really calling for meta expertise of different sorts to be involved in research? So you talked about statisticians, but do you think we also need philosophers of science, sociologists of science, historians of science maybe to get involved in research?
That's a difficult question. I'm very much biased by being a statistician, of course. I would say in general, the more people from more and the more diverse the fields from which interest in this topic is shown, the better. We can make this a huge success if there is enough mass, if enough people from different disciplines find this important. And as I said, I think these are the right times to do that.
All right, thanks. So another question from the audience, Krishma Labib. So they're asking, how can institutions encourage researchers to consult with statisticians? Sometimes statisticians are not available or not the most approachable people. So is there something that needs to be done there? This wasn't a comment about you personally, obviously.
Well, wait and see. First of all, I've seen in our university, but also in other universities, that if we would put into practice what I'm preaching, we need more methodologists and more statisticians. Obviously, the number of people we have who are skilled in these disciplines is relatively small, and we simply need more of them. I think it should be the policy of a school and of a university to require of methodologists and statisticians that they work together with people from substantive fields. Not only do their own research, which from my own perspective, I can promise you is extremely interesting. But of course, then it becomes very attractive to only do your own research. Part of the job should be to engage in consultation, work together with other researchers from other fields, publish together with them, let them profit from your expertise, and in the run also learn something from them.
Yeah, so this ties into a further question that we received in the Q&A by an anonymous attendee. To what extent are these collaborations a two-way street? So you mentioned that biologists, sociologists, psychologists need to get statisticians involved. Is it also a call on statisticians to become more involved in and learn about biology, about sociology, and so on and so forth?
Well, I would say, I was a psychologist by training and also a statistician by training. I combined the two, because of that, it is quite easy for me to work together with psychologists from different fields. I'm not claiming I'm an expert in those fields, but absolutely not. But at least I understand their language, and that's easy for me. And when we work together, they make me read stuff they do. I make them read stuff I do, and we combine those areas in order to have a good result. And so, by working together with people from other fields, you automatically learn from those other fields. It's not only doing a t-test or something that is a little bit more complex, but it's also learning about the research questions, how to formulate them, what's behind them, etc., etc.
All right. A question from Jeroen de Ridder. He's wondering, do we have enough statisticians to accomplish all this? If you really want all these statisticians to be involved with all these different fields, are there enough of them? Do we need to educate more? How's that going to work out?
Yes. We don't have enough statisticians, so that's a clear answer, and we need to educate more. That's also a clear answer.
Very clear, yeah. Thank you so much. So I have some statistics from a poll that we did. So the question was, how many of the audience members feel adequately supported by their research institutions to deal with research integrity? So 29% said they felt completely adequately supported. 43% said somewhat adequately supported. 20% was neutral, and then a couple of other smaller percentages for the other categories. Do these numbers surprise you? Does this ring true for Tilburg or?
Well, I didn't expect particular numbers, so I can't say they surprise me. But I know we're still in a long trajectory, coming from very little awareness about these issues to complete awareness about these issues and making them part of what we do. And we're somewhere halfway, I guess.
All right. We have at least one anonymous statistician in the audience who's wondering, and this is, I assume, based on personal experience, the excuse they always get is that there's not enough money to involve a statistician in research projects. Do you think that's a valid concern?
Well, it can be a valid concern, I guess. But what you can also do is involve a statistician and let the statistician be, if the contribution is big enough, let the statistician be a co-author on the papers. I mean, then you don't need money, but it becomes profitable and attractive in another way.
All right. So co-authorship. All right. So one final question.
I cannot hear you.
Oh, sorry. One final question. Is this better?
The sound is very, very low. Very.
Okay, I'm looking at our tech people here because I.
Yeah, now it's okay. Now it's okay.
Good.
Yeah,
we're good. So one final question I want to say. Do you think? A question from Koosje Veldkamp. Including a statistician before data collection, so in the phase of study design, might help to avoid a lot of these troubles. What do you think about pre-registration of studies and including statisticians even in the writing of research proposals and protocols?
Well, I would say the sooner the better. When I started my career early 1980s at the Vrije Universiteit, we already said this to one another. So it's a relevant insight, and it's also an old insight. So involve a methodologist or a statistician as early in the process as you can. And I think there was another question, but I forgot that one.
I think you answered the question perfectly. Which is a good thing, because we are officially out of time for this particular part of the program. So a very, very big thank you to you, Klaas, for an inspiring talk and some very helpful advice to all of us. Thanks for joining us this afternoon.
You're welcome, and thank you for listening to me.
Thanks. I'm going to introduce our next speaker. He is Assistant Professor of Political Communication and Journalism at the Amsterdam School of Communication Research at the University of Amsterdam. His main research interests include the psychological underpinnings of political belief. And he became sort of well known for trying to do a good thing and to replicate an influential study, but then ran into some trouble, we might say, in trying to get that study published. He's going to speak to us today about politicizing research and the effects on research integrity. Bert Bakker, over to you.
Thank you, Jeroen, and thank you for the organizers. I believe you see my screen now. So I'm going to talk a bit about it's going to be a bit of a personal story, which is interesting in a environment where I don't really see as anybody aside from the presenters. But I'm going to talk through the process of replicating an influential study and what happened in that process, what I've learned about research integrity and how that has changed how I think about my own research and doing research in general. So. The whole enterprise started with how we think about politics, and you only have to pay a little bit of attention to US politics and how that is covered, is that we see that people on the left and right, liberals and conservatives, Republicans and Democrats, are seen as people from two different worlds. They're standing far apart from each other. They perceive they have different views, they see the world differently, and they vote for different candidates. And a long history in both psychology and political science has attributed some of these differences to deeper-seated underlying psychological differences. So people from the left have a different psychological makeup than people from the right, and as such, things like polarization might not only be the consequence of the politicians itself, but it might actually be the consequence of who we are as persons that we bring into the political arena. And this you can see in many research, in many public outlets, like this is Business Insiders, like there are key psychological traits that make you either liberal or conservative, and kind of deterministic. If you have these traits, you are either left or right. But a lot of this work was done, including by myself, based on correlating self-reported political preferences to self-reported psychological traits, such as the Big Five traits or other sort of traits. But it's obviously hard to disentangle this and get at the causal effects. But in 2008, so a long time ago, John Hibbing and Kevin Smith, with a team of co-authors from the University of Nebraska, published a rather groundbreaking study in Science. They said, well, it's not only the psychological self-reports, but they're actually an underlying deeper-seated physiological trait, how you respond to threatening images, and that correlates with your political beliefs, being that the people who held more conservative policy positions, so opposition to gay rights, immigration, would respond, had stronger physiological responses to threatening images compared to liberals, who were more pro-gays, pro-immigration, etc. The study was run in Lincoln, Nebraska, among 46 people, and really laid a foundation for a line of work on sort of the biological roots of ideology. So is there something deep-seated and hardwired in our ideological beliefs? But it also fitted, and this is for me, I was a student at the time thinking about going into graduate school, and I really believed this study. It also fitted with how I perceive the world. People from the left and right are different. And here we have these underlying deeper-seated physiological trait that correlates with your political beliefs. So there might be really something on this bottom-up approach. It comes from the wires, it's actual science. It was published in Science. But coming to Amsterdam after a PhD abroad, I realized that, we only notice it when other laboratories weigh in. And this is also what the original authors wrote a couple years after. Say, whether or not this replicates, we don't really know. So I coming to Amsterdam, decided that I wanted to replicate this study. And with a collaborator in the United States, Finn Arsenault, we started to include some of these images, still believing this line of work. We said, well, we include some of these threatening images because then we can also benchmark our own findings to their findings. We were interested in how political rhetoric might evoke certain physiological responses, but we say, let's also try to replicate the original study. And in these conceptual replications, 340 people in the US and 80 in the Netherlands, we really found basically no correlation between, very close to zero, between the physiological responses to threat and your self-reported conservatism. But you could say, well, the images were different and the measures of ideology were different and the lab protocols differed. So, does this really speak to the replication of this original study? And so therefore we decided to do a pre-registered replication of the original study. And so in our lab in the Netherlands and in Philadelphia, in our lab in Philadelphia, we ran people through 200 people through a study where we measured these physiological responses, use a skin conductance. So the idea is if you get more aroused, you'll get more sweat secretion in your fingertips, which the electricity running through these electrodes is better conducted, and we get a higher level of arousal, and that should correlate with your self-reported conservatism. So we pre-registered, we used the original stimuli that we got from the original authors. We tried to copy their protocol as good as we could. We used over 4 times as the number of responses that the original authors used. And said, well, let's just see what happens. So we replicated it with a protocol which more or less looks like this. So participants sit in the lab and they look at a blank screen, and then there is a somewhat scary picture coming into your screen, like a spider or a knife or something else. I'll put it away. And so the first question we pre-registered is actually, is there something like a physiological trait to these threatening images? Because we're also a bit skeptical based on the literature that this was actually a thing. So what I'll show you is a correlation matrix of the relationship between the 3 original images from the science paper and the physiological responses to these images, and and what you see here is that there's basically the correlations are negative and they're very close to zero. So there's not much evidence that there's actually an underlying physiological trait to these 3 images. If we then correlate the index of these 3 images with conservatism, you probably expect that there's no really strong correlation anymore, and that's indeed true. The second question was, do political attitudes vary with physiology? And here you see 2 dimensions of conservatism, social and economic policy attitudes, and the point estimate is really close to zero when we look at the threatening images. And its correlation with social conservatism. And also if we decompose it to look at the individual images, point estimates are very close to zero. They should be positive and statistically significant, but they circle around zero. Some are negative, some are positive. Bayesian analysis also suggests there's more evidence for the null than for the alternative hypothesis. And a whole bunch of robustness checks actually also did not give any evidence that we could find a subgroup of people who would be for whom there would be a positive correlation between self-reported conservatism and these physiological responses. So we wrote up the paper and said send it to Science. Science desk rejected it under the argument that this would be a discussion for a subfield and not something for the general journal. We appealed because we said, no, this paper is actually been feeding a whole discussion both in the broader society but also in academia about the sort of underlying biological component of ideology. Well, it got rejected there. I still disagree with that that the desk rejection policy, it should have at least been sent for peer review, in my opinion. But the good thing is obviously it got published this year in Nature Human Behavior. But what I want to end is actually not so much with that it had a happy end for me as a publication, but it changed the way I learned a couple of really important things here. The first is, if I now read the science paper, the original study I tried to replicate, I think, Bert, how did I ever believe this original finding? It had a small n, the p-value was pretty close to 0.5 and sometimes at 0.05. It looked too good to be true, but it also fitted with my beliefs of how I and a broader literature have been talking about the ideological differences between the people on the left and the right. And perhaps that has blindfolded me a little bit for some of the flaws or questions you could have with the design of the study, a small and only a couple of images. And so I could have been more critical. And I think what I've also learned from this is that once you see something that fascinates you and you want to build your research on this, is first try to replicate it. The original study was published in 2008, and we published the replication in 2020. That's 12 years later. And there are probably quite some other people that have been inspired, bought lab equipment, started to trying to get at biological roots of ideology, or do all sorts of extensions, but we haven't really replicated the original findings. So what I'm trying to do now is much more replicate my own findings. If I find something that is interesting, even if it's pre-registered, can I replicate it again? Can I extend on it? So much more, be more critical about these original, maybe flashy findings. And the other part is that pre-registration is a crucial thing that I've adopted ever since this project, is that especially with stuff that is a little bit more than a Likert scale, there's so many analytical decisions to make with physiology in a lab study. You can analyze the data in so many different ways, and pre-registration makes me think about the design and the expectations much clearer than I used to do. So my work gets better, but I also don't fall into the sort of garden of forking paths of all sorts of analytical decisions I have to make. So to sum up, I think actually this process has made me a better researcher in the end. I am much more critical in how I read the work of myself and of others. I think replication is a crucial part of what we do, and that pre-registration and extensions are now the standard way in which I do my research. So I think it has brought me a lot. And I've also contributed a little bit to science by publishing a replication in a journal that people maybe read at times. So thank you, and I look forward to hearing questions or comments on this talk.
All right, thank you so much, Bert, for sharing a bit of your personal experiences and journey with this particular study. I wonder, can you comment for us on whether you think the original study should never have been published? And if so, was it, were the researchers to blame? Was it the journals who were to blame? Was it, the media and the press who sort of picked up a poor quality study?
Thanks for asking this question. I think the original authors have been an example of how you should deal with replication. So Kevin Smith, with whom I have very good contact, wrote me a couple of, once we started replicating and he saw our original conceptual replications fail, he said, Bert, I'm not super excited that you failed to replicate my work, but if this is what it is, then this is what it is. Science has to progress, and if that means that my original finding might not be true, then it might not be true. So I think perhaps reviewers and editors could have been more critical, but I don't think it's in this particular author team has much to blame, in a sense that they have also this is done in a different time, in the mid 2000s, where smaller sample sizes were probably still also somewhat more accepted. Now, if I talk, there was a science paper with 46 people. Somebody tweeted once we started talking about it, it's like, well, somebody tried to replicate a science paper with 46 observations. You guess what happened? And so I think, looking back, it's easy to blame or to suggest all sorts of things. I try not to do this, because I think they did this with all the best intentions at the time. This is at least how I'd like to think about it. And but I do think that the journal, in its once the replication effort came in, I disagree with the point that replications are only relevant for subfields, because if you publish the flashy finding, that still gets media attention. This paper still, in the wake of the Trump election, is getting attention that, this is because people are so different biologically. Yeah. I think if that's what you originally published, I think you should also at least give the replication a fair chance of going through peer review.
Yeah.
I'm not saying that by a replication you deserve, because the reviewers might have said, this was actually poorly done, or I actually don't believe that this is an actual good replication. So I think there's not so much to blame for the author. I think the way the journal dealt with the replication is something where I have some questions about.
All right, thanks for commenting on that. I want to squeeze in one final question from the audience, and maybe you can answer in 2 or 3 sentences, which is a challenge. But the question is, can you comment a bit more on how pre-registration is going to help to address these issues and so the problems that you ran into?
Well, I think what I've learned with the pre-registration of the replication is that we pre-registered a whole bunch of robustness checks. So we say, is this conditional on the race of the respondents? Is this conditional whether or no you know a lot about politics or not so much about politics? All sorts of things that we in political science communication care about. And so you can specify a whole bunch of alternatives, or you can do what we call maybe a multiverse even, is that just do endless numbers of specifications. And I think pre-registration also for replications help because you become incredibly clear about what you're going to do and all the analytical and steps you're going to take. And in that sense, pre-registration of replications is nice, but it's generally, I think, just makes your work better because you have a much more detailed discussion with your advisors or your colleagues about what you expect, how you test it, and how you analyze it.
All right, thanks so much, Bert. That is solid advice. Thanks again for contributing to our symposium today. We're going to go to the next speaker, so thanks for joining us, Bert. Our next speaker is Roeline Pasman, Dr. Roeline Pasman. And one thing I would like to emphasize is that we like this conversation about research integrity to be something that involves different disciplines and different sorts of methodologies. And I was excited to see in the results of the poll that we have participants in the online symposium from a number of different fields. So roughly half are from the biomedical sciences, 36% from social and behavioral sciences, and 32% from the humanities and the arts. So that is exciting. Let me introduce our next speaker. She works as an associate professor at Amsterdam University Medical Center at the Department of Public and Occupational Health. She is a sociologist by training, and her field of expertise of research is end-of-life care, where she employs mainly qualitative research methods. So she's going to talk to us about research integrity in the use of qualitative research methods. The screen is yours, Roeline. Welcome.
So thank you very much for this introduction. I hope you can all hear me well and see my screen. As you said already, I'm a sociologist and a nurse by background. And I did my PhD in a nursing home, and I did an ethnographic study. And the field I'm working in today, and actually from my PhD on, is in the palliative care research. And with our research team, we do qualitative studies, quantitative studies, and mixed method studies. And I do a lot of qualitative studies indeed. And therefore, I'm very pleased to have the opportunity today to talk to you about research integrity and qualitative research. I will start with some background about qualitative research, as possibly not everyone in the audience is familiar with it. Then I will highlight 2 characteristics of qualitative research that are important to research integrity, and some final remarks. So to start with the goal of qualitative research, there are a lot of descriptions of what qualitative research is. And I picked one that's used in a series about qualitative research methods in the British Medical Journal already in 1995, edited by Mays and Pope. And in their first paper of this series, it's titled Researching the Parts Other Methods Cannot Reach. And there they say that the goal of qualitative research is the development of concepts which help to understand the social phenomena in their natural setting rather than the experimental setting, giving due emphasis to the meanings, the experiences, and the views of all the participants. And to emphasize the characteristics of qualitative research maybe a bit better understood, it's when you can compare it to quantitative research. So I made a slide where to compare it a bit. So when you look at the general framework of quantitative research, you want to confirm hypotheses about phenomena. And in qualitative research, you want to explore phenomena. In quantitative research, you use structured measures like questionnaires or surveys, where in qualitative research, you often use semi-structured measures like interviews or like observations. When you look at the objectives, quantitative research looks for to quantify variation and to predict causal relationships, where in qualitative research, you want to describe the variation and describe and also explain relationships. And the third difference is the flexibility of the study design, and I think that's the most important one for today. Where quantitative research is stable from the beginning to the end, qualitative research has a more iterative design, and the data collection can be adjusted according to what is learned. So that's totally different from a lot of quantitative studies. And I think this graphs show it nicely. On the left, the quantitative, where you see that you first collect all your data exactly in the same way, and then you do the analysis. Where in qualitative research, you start with collecting your data, and as you have collected your first data, you start with your analysis, and then the first analysis will feed your data collection for the next round. So you use your first analysis to get a better understanding, and then your further data collection can be more precise, or you can add questions which come from the first analysis. So these differences in objectives in study designs might ask for specific approaches for conducting sound research. But when we look at the Netherlands Code of Conduct for Research Integrity, conducting sound qualitative research actually isn't so different than from any other approach. The principles and the standards are quite general, and qualitative research can and should adhere to these principles and standards. And the difference is more in the procedures, how you adhere to these standards, I think. And as I said before, I want to discuss two characteristics of qualitative research, which I think are important for research integrity. And the first one is the flexible and iterative process, as I mentioned before. And the other one is that as a qualitative researcher, you're often your own research instrument. But let's start with the first one, the flexible and iterative research process, because of the flexibility that really asks for transparency. And transparency is one of the standards in the Netherlands Code of Conduct for Research Integrity. And it says that you should be transparent about your methods and your procedures, that you should write it down in logs or in lab journals, and that the steps of your research process must be verifiable. So this usually means that the research must be described in sufficient detail for it to be possible to replicate the data collection and its analysis. Now, replication in itself is difficult in qualitative research, maybe impossible because of this flexible and iterative design, because you follow up on answers of your participant, of your respondent. It's really hard to replicate. But that doesn't mean that you have to be verifiable and that your research process must be open. So it's more, however, it is very important to show in qualitative research, or maybe it's very important because of the flexibility, how and why you come to your conclusions by making your process visible and making your process retractable. And it's also important to give enough detail of the context for others so they can translate or transfer the results of your study into their own context. So maybe not replication, but for sure verifiable and that it has retractable. So how do we do that in qualitative research? Well, in the standard already it's mentioned that you can use an audit trail that you report. And in qualitative research, we often use field notes for that. So you can have a kind of log or a diary in which you document your research decisions and your activities. But you can also have more specific field notes like methodological notes and theoretical notes. And in the methodological notes, you write down the changes you made based on your first analysis. So your methodological changes. For instance, if in the first interviews you did, there's a certain topic that's coming up, and you want that topic to include in the rest of your study because it's interesting and it's relevant for this study, then you write in your methodological notes that you added an extra topic in your topic guide, and also why you did it, what made you do that. And the other one is the theoretical field notes. And there you write down your first ideas of the analysis, because you start analyzing at the beginning, your interpretations and your explications, just to keep them in mind. And when you are further on in your process, you can look back and look what first thoughts you had and if they are still applicable, if you think it's still applicable. So that's important because the design is flexible. Well, the other characteristic, as I mentioned, is that you're your own research instrument. So data collection and analysis are highly dependent on the individual researcher. And they also can be biased by your own convictions or your own background as a researcher. And for instance, when you're interviewing, you have to decide what follow-up questions you will ask at that moment. So you have only your topics, but you have to think which research questions or which next question you will ask. So go with the answers of the respondent. And this is on the one hand a strength of qualitative interviewing, because then you really can get the in-depth that you want. But at the same time, it can be a pitfall or even a threat when you're too subjective or too prepossessed. So that's a threat of sound research. So to safeguard this bias, a researcher should be reflexive, a qualitative research. I think a quantitative research should also be reflexive, but it's even more emphasis on in qualitative research. And you can do that in different ways. You can already start, before you start a study, think about, to be aware about your own background and also think ahead of the consequences. And for instance, in my own research field, we do a lot of research on euthanasia. And when you have a specific stance on euthanasia, that can hamper your reflexivity, or that can hamper, and then you can maybe influence your questions and your analysis. So it's good to be aware and to think ahead of those consequences.
Roeline, one more minute. I'm sorry to interrupt you.
Yeah.
1 more minute.
Okay. The other thing is the peer debriefing. You can also have some reflexivity during your research. Ask peers and discuss with peers your first analysis. And you can also ask them to, for instance, listen to an interview of yourself if you're not too influential. And you can have field notes, reflexivity notes, in where you write down your own thoughts. So to conclude, research integrity, what it means to qualitative research, well, actually a lot more than I discussed in these 10 minutes, but at least you should be transparent, you should be reflexive, and what I didn't mention before, you should be prepared or well educated. And I think that's the same as Klaas told in his first talk about that you have to know a lot to be a statistician. You also have to learn and know a lot about qualitative research to be a sound qualitative researcher. So thank you for the attention.
Thank you very much, Roeline. That was very helpful and inspiring. I have a question from the audience. What do you think the role can be of pre-registration in qualitative research if there is this flexibility to adapt the research design to the ongoing research process?
Yes, that's an interesting question. Not so easy, but I think you can write down what your overall aim is. And you can already put down what your research methods will be. And I think you can also reflect already a bit on who you are going to include in your study. So I think you can at least have your broad research aim can be written down before, and people can also have a look at it.
All right, thanks. Another question from the audience. So someone is worried that there might not be enough space within the word count of a typical journal article to address these reflexive issues. How do you deal with that worry? That
is true, and that's important. Sometimes you can use some additional boxes or so you can put in something, but I really am in favor to put as much in the method section how you did, because I think it's important that also readers can follow what you did. But boxes and supplements are a real good solution to give more insight in what you did. But it is a problem, for sure, if you want to publish in medical journals.
Yeah, exactly. So a final question from the audience, Bart Penders. How would you bridge the contrasts you identified in the case of mixed method research in terms of replication and the other things you mentioned?
Can you say the question again? Because in mixed methods, you try to combine the qualitative and the quantitative results. And what was the question exactly?
So the question was, how do you bridge the contrast between these different styles of doing research, these different methods that you're using?
Actually, they are complement to each other. So what you find in your quantitative research, and you have questions that you don't understand, you can use qualitative methods to get more insights in your quantitative data. So actually, it is a real strength when you can use both methods.
Good,
and it can help you to understand the figures or to give a word to the figures. Yeah.
All right, so they're largely complementary, I guess, is what you're saying.
Yes.
Good. So we're out of time, so I'm going to thank you for a very helpful and excellent talk. Thanks so much for joining us here today, and we hope to see you again in the final panel later this afternoon. Thanks for being here.
Thank you for being here.
All right, I'm going to introduce our next speaker, and at this point in the program, we're going to talk about open science. Daniel Lakens, Dr. Daniel Lakens, is an experimental psychologist working at the Human Technology Interaction Group at Eindhoven University of Technology. And in addition to his empirical work in this area, in cognitive and social psychology, he is very active in helping to promote better research methods, better research integrity, and in particular, better statistical inferences. And if you've had a run-in with him on Twitter, maybe, you know, he's a fierce but also very constructive critic. So I'm excited to have him here on our screens this afternoon. Over to you, Daniel.
Okay, hi, good afternoon. Thanks for the introduction. And yes, indeed, I am sometimes passionate about certain aspects of doing better science. And maybe because we've been trying to improve things for a very long time, and sometimes we need to be a bit harsher, maybe. Let me start by pointing out a quote from a book from 1830 by Charles Babbage. The book is called On the Decline of Science in England. And this is 1830, right? So we've been trying to improve the way we work for 200 years. And here he describes a practice that is called off-cooking. And he says, this is an art of various forms, the object of which is to give ordinary observations the appearance and character of those of the highest degree of accuracy. So scientists are trying to make things look better than they are. And he describes one way in which they do this. And he says, one of its numerous processes is to make multitudes of observations, and out of these to select only those which agree or very nearly agree with what we are predicting. So this is selective reporting. Scientists 200 years ago were doing this to an extent that Charles Babbage was already upset with this. And it's interesting to think of whether after 2 centuries we might be in a place where we're going to fix this finally, because I think it's important. And opening up the research process, I think, is a crucial aspect of making sure that we prevent these kind of things. So maybe you want to briefly reflect on this simple question. It's part of research, and I'll show you the results on the next slide. But the question that was asked is, a scientist runs several experiments, but only reports those experiments that show the results they want to see. In your view, how morally acceptable or unacceptable is this? And now many of the people here will be scientists. I would highly recommend to ask this question to your grocer or your baker or your hairdresser next time that you go into the normal world and you talk to real people and ask what they think about what scientists are doing. And that's what they did in this study by Pickett and Roche, 2017, done in the US. Not surprisingly, when they ask about certain things, falsification, they also asked about this, clearly wrong, but also about selective reporting, just this question that you just saw. And what does the public think? Well, they think it's morally unacceptable, 71%. 63% doesn't think it's unreasonable to expect that the scientist is fired if they do this, selectively reporting, through numerous processes, like this cooking that we saw that has been going on for 200 years.
Daniel, can I briefly interrupt you? I think you forgot to share your screen because you are referring to slides and we're not seeing them.
Oh, sorry. Okay, I thought I selected it, but I probably didn't. Yeah, can you see it now?
Yeah, we're good.
All right. Well, you didn't miss much. It's fine. So here you can see the numbers and the citation if you're interested. So they say 73% of the general public thinks it's fair to receive a funding ban. And there's even a subsection, 37% of people that think that selective reporting should be a crime. So this is what the general public thinks that we should do. Now, we can also take a look at what scientists are actually doing. And we have some numbers about this, thankfully, due to things like meta science. So we have meta scientific research where we look at the scientific process. Before I show you those results, just as a reminder, we already have a code of research integrity that tells us what we're supposed to do. And it says that withholding research result is deemed unacceptable, right? Negative results, especially, we should share this. We cannot selectively report things. In this study, 2014, by Franco and colleagues, they looked at what people do with research results that were performed. And we know this because this is a nationally representative data collection effort in the US. People can submit a research idea, and if it gets approved, then the data will be collected for them in a nationally representative survey. So we know that people have been approved these studies. They are performed. And then what the authors did is just ask after a couple of years, so what did you do with this data as a function of whether people observed no results, mixed results, or strong results? And not surprisingly, the strong results that supported claims have been published, large majority. Some are unpublished but written up, still undergoing peer review. The story for no results is exactly the opposite. People very often didn't even bother to write up their no results. And remember that these are results where they first requested a grant for to be collected. And also that these are not large nationally representative samples. So it's very high quality data. And then even then they didn't bother to write it up. Psychologists, that's my field, have been looking at what we are doing for a while. And the story is not very different than Babbage mentioned 200 years ago. Psychologists admit that they selectively report studies with respect to certain findings that worked at least once in their career, but many other people have done it, I guess, more than once. And again, this is actually directly against what the code of conduct tells us to do, right? I mean, it feels a bit silly to keep reminding you of the fact that what people are doing in practice is against the scientific code of conduct, but it's worth pointing out nevertheless. There are some other practices that scientists admit to doing, so selectively reporting measures or conditions, optional stopping, which was already mentioned at the beginning as well, as a way to improve the chances of finding a significant result. And I think Michelle Nuiten might say something about incorrect rounding and how we can find this in the next presentation. When finally we would like to see what's going on with this data and we ask people about it, people don't have the habit of sharing these findings, so they don't want to share their results. Very few scientists, when directly asked, actually give access to their data. Now, we're interested, of course, we are here at the launch of a national survey among researchers. But what I want to say is it's useful to also think what the general public thinks. And I already showed these data earlier. I think it would also be interesting what the Dutch public thinks. We've done a small pilot together with Anna van Veer and Maaike Verburg, where a couple of weeks ago we asked 200 people on Prolific, but these were Dutch citizens and Dutch-speaking people. What do you actually think about these practices? Not surprisingly, when you ask them on a scale from 0, absolutely not morally acceptable, to 100, most people actually don't like it that we selectively report findings. Just as a reminder, if they hear and if we explain them what happens with publishing only positive results, but not the results that we did not find, people are again not very enthusiastic about what we're doing. They think this is not morally acceptable. And finally, if scientists don't share their data, large group of people also thinks this is completely unacceptable if scientists do this. Whereas we have just seen on the previous slides that this is exactly what people do. This is the normal modus operandi, I would say. So I think that if we think about open science, very often we think about sharing data and having public access to papers that we wrote, which are all very important. But we also really need to think about transparency. The transparency of reporting everything honestly in line with what's mentioned in the Code of Research Integrity. Earlier, Bart already mentioned registration, pre-registration, and registered reports are one way in which we now have recently improved the openness and the transparency of results. In a registered report in psychology, people submit the proposal, the theoretical rationale, and the analysis plan for review before the data is collected. They receive an in-principle acceptance if peers think that this is an interesting data set to collect. And then afterwards, the data is published regardless of whether the p-value happens to be relatively high or low. And if we look at what happens in these registered reports, all of a sudden we see that compared to standard reports, the normal literature, if we quote whether people support their results, we see that large majority in standard reports still has publication bias. This is from very recent papers, recent data, work by my PhD student, Anne Schil. But if we look at registered reports, only around 44% of the findings actually support our predictions. So it's possible by opening up the research process and having these new initiatives to have a scientific literature that looks a little bit better and more in line with what hopefully people would find also an ethical way of working. So we have these questionable research practices, and I think that open science can move us into a more reliable and honest way of working that increases the accountability of scientists. Thanks.
Thank you so much, Daniel. That was perfect on timing. I want to emphasize that I reject the implication that scientists are not real people. Let that be clear. So here's a question from the audience. If negative or no results, a question by Ellen Schenk, I should have said. If negative or no results are as important as positive results and publishers agree on this, is there an equal balance in journals in this respect? So what about the journals here?
Yeah, I think that there's nowadays enough space to publish things. And I'm not sure where we want certain things to end up in the scientific literature, but there are enough journals that can publish things and that publish high quality research, regardless of the findings. So is there enough space? I think so. We should prioritize things like the story that Bert Bakker just mentioned in the beginning. That was a very important study. And Science also publishes many studies that are not cited a lot at all. So they were probably better off by publishing a follow-up study on something like this. And the same can go for important null results. Not all results are equally important, but some of them I think we can agree on. Also, null results deserve publication everywhere in the highest outlets, I would say.
All right, good. A question from Ronald Verhuizen. So you refer to some publications from 2006 and 2015. Is it your understanding that data sharing has improved since then? Are we on the right trajectory?
Not so much, especially not if we don't have any policies in place. The best I've seen is also from an earlier study that we did in our lab where we looked at these registered reports. So people who are adopting these registered reports are sort of forerunners. They really like openness and transparency. But even there, only about 60% of people share the data out of their own free will. So even there, the numbers are not up to the 90% or something, which I think we should see if people share data whenever it is possible. There is a small increase, but it's not going as quickly as possible as we would like to see. And I think policies are probably needed to motivate people a bit more.
So yeah, I'm curious about this. What do you think accounts for this? I mean, is it the policies? Is it sort of lack of motivation on the part of individual researchers? Lack of incentives, maybe?
Yeah, I mean, we should remember that putting things for free on the internet is relatively recent. When I was studying 20 years ago, it wasn't so easy to just throw things for free on the internet forever. So we don't have the training to do this. So that's one thing. People don't know how, so they might be a bit unsure. And also it's just a bit of extra work. And every extra work, if you don't have to do it, you might not want to do it. So we have to expect this from people and hold them accountable for this, to make it happen, I think.
Yeah, I know that feeling. If you don't have to do it, it's sort of tempting not to do it. So a question, I guess, sort of a devil's advocate kind of question from Max Kenman. How do null results improve our knowledge of the world? Aren't there enough publications already?
There are a lot of publications. It's interesting to compare how we work with different fields. So if you look at physics, for example, they have a huge number of well-informed theories that have something going for it. And they would like to just check them off if they don't work as well, because they have so many theories that many of the findings there are null results, and they're published most of the time. The important thing there is they have strong theories. A null result is interesting if the theoretical idea tests is important to be proven wrong. Now, whether that holds to the same extent in all fields might be a question, right? So I think we have to have very strong theories, and then the null results should be interesting. And if not, we might also doubt a little bit whether the finding would be interesting if it was a positive result as well, right? Without any strong background, I would say.
Yeah. All right. Final question from Mirjam Erlings. In pre-registered reports, how do authors deal with the time that is needed for peer review, since no data collection can be done in that time?
Well, let me start by saying this is the perfect time to pre-register your study, because you're not going to collect real life data anyway. So I would say that if this is a concern of yours, then you can move the whole peer review process forward now for ongoing work. So start pre-registering everything you do at this moment. It works better if you have multiple research lines where you set up the study and then you have to wait for the review process. That's true. So you have to do something else in that meantime, but you only do that once. Somewhere you have a break, and then afterwards your cycle keeps running as normally, at least in my experience. And it can be true that you think that in the last year of a PhD student's process, you don't want to pre-register the study because there's no time to wait. And by all means, then if it's really so inconvenient at this time, then don't. I mean, yeah.
All right. Thanks, Daniel. That's very sensible advice. Thanks so much for contributing to our symposium, and we'll talk more with you later during the panel. Thanks. Our final speaker during the first half of this symposium is Assistant Professor at the Meta Research Center at Tilburg University, Dr. Michelle Nuiten. She studies ways to assess and improve the replicability and reproducibility of psychological science, and she co-developed the tool StatCheck, which is a free tool to improve your statistics. It's kind of like this paperclip that Microsoft Word used to have, I guess. So really exciting to have you with us here today. Michelle, the screen is yours.
Thanks. I love the Clippy reference. That's exactly what we were going for. I'll mention that later on in my talk as well. Let me share my screen with you. All right. So today we're talking about a lot of topics that have to do with integrity, and integrity is a pretty broad topic. But from my sort of point of view, and my background is psychology, so I tend to have a very sort of empirical focused quantitative view on these things. The main thing that I would be interested often is robustness of a result. So today I would like to quickly talk about an idea of a 4-step robustness check. So before I dive into that, we have to talk a little bit about robustness. What does that mean? And that's a pretty difficult question, and I want to shy away from giving you like a formal definition because then I might get into a fight with the philosophers of science and people who find semantics very, very important. So by now it's sufficient for me if we are all pretty much on the same line. What do I mean with robustness? Well, what I mean with that is, say that you're reading a paper, and in the paper they state, we found an effect of X on Y. Then robustness in my mind would be, can I trust this result? Does this make sense? Will it hold up? Can I trust this? And this is an important question, and probably one of the main questions that we usually talk about also when we talk about integrity. We want to make sure that the scientific findings that we publish are robust and trustworthy. So a lot of suggestions in psychology, but also in related fields, and we've already heard something about it, is to assess robustness through replication. So in other words, to redo the study in a new sample. And then maybe you conclude that, well, your replication does not find an effect of X on Y, also as we just saw in the example. And this is great. I mean, this is a very important part of science, but there's a pretty big disadvantage of replication studies, and that is that it takes time and money to conduct one. And what I would argue is that we can maybe find a more efficient way of checking robustness without immediately having to spend this time and money. I would argue that we have to focus on reproducibility first. And now we're getting into a bit of terminology, and since the words reproducibility and replicability and related words are often used sort of interchangeably, just to make sure that we're all talking about the same thing. If I talk about replicability, I mean the following. A study is successfully replicated if the same or a similar result is found in a new sample. Whereas with reproducibility, a study is successfully reproduced if independent reanalysis of the original data using the same analytic approach leads to the same results. Now, why do I think we should focus on the latter first, like on reproducibility? Because reproducibility is a prerequisite for replicability. So think about it. If we have this paper and they conclude we found an effect of X on Y, P is smaller than 0.05. Often in psychology and many other fields, this cutoff of 0.05 is taken as sort of a magic boundary, if you will, after which you conclude that your effect is statistically significant, and often people go as far as to conclude that this is proof that the effect exists. So there's a lot of focus on this number. But say that I have the original data that underlies this study, and I reanalyze this data following the exact same procedures as the original authors mentioned. Then it's possible that maybe I find a different number rolling out. And this may sound very strange to some of you. I will show some prevalences later on, but this can happen. And this means that somewhere in the pipeline, a mistake has been made. So the number that's in the paper cannot be reproduced from the original data. Now, what does that mean? That means that if a result is not reproducible, it has no clear bearing on theory or practice because I have no idea where this number comes from. And that means that an irreproducible number is effectively meaningless. If I cannot sort of verify where this particular number comes from, I cannot interpret it. And that means that I don't need replication to find out whether this finding is robust or not, because it's not, because this number is wrong. So that's why I think that reproducibility is a prerequisite for replicability. And that's why, kind of already my take-home message is to verify reported numbers before investing in a replication. Now, I said take-home message. I'm not going to let you go home yet. I have a couple of more details about this, because how should we do this? Well, the way that I sort of envision this, verifying numbers, is in a four-step check, if you will. And I think the first check should be, are there visible errors in the reported numbers in the paper? The second step could be, does reanalysis of the original data give the same outcomes? Then you can check how sensitive is the result to alternative analytical choices. And finally, does a replication study in a new sample find the same results? I want to quickly tell you a little bit about these individual steps, because I can imagine this may sound a little bit abstract. So if we focus on the first one, are there visible errors in reported numbers? What do I mean with that? Well, consider the following result. Say that you read this in a paper. 70% of the patients recovered within a week, 60 out of 100. This is an internally inconsistent set of numbers, because if I would recalculate the percentage based on the frequencies that are mentioned, it would be 60%. And maybe this one, in total, we interviewed 20 residents, 11 men and 12 women. Well, this is also inconsistent, because if I recalculate what the total number of residents should be, it's 23. And we can also do this slightly more sort of advanced. If I report a result like this, the effect was significant, a t-test of 28 degrees of freedom, a value of 1.02, and a p-value of smaller than 0.05. Now, the nice thing about results like this is that they work the same as the examples above, in that I can recalculate the p-value based on the degrees of freedom and the reported test statistic. And if I do that, then my recalculated p-value is actually 0.32. Now, the mention was already made about the program that I wrote together with my colleague Sasha Epskamp. It's called StatCheck, checks for these kinds of errors. Now, the second step, does reanalysis of the original data give the same outcomes? We've already discussed that. So that basically means you take the original data, you reanalyze it following the reported procedures, and then check whether the same number rolls out or a different one. And then third, how sensitive is the result to alternative analytical choices? This is something that was already referred to. Maybe if you reanalyze following the reported procedures, you find the significant effect. But if you make small changes, maybe if you remove one seemingly arbitrary covariate, you suddenly have a p-value of larger than 0.05. Or if you include that one outlier that the authors removed, then suddenly the effect disappears. Or if you do a two-tilt test instead of a one-tilt. Or if you exclude the last observation because you're afraid that optional stopping may have taken place. Well, if you see a pattern like this and only one very specific and seemingly arbitrary analysis path leads to a certain result, then you can wonder, how robust is this? Now, how common are these reproducibility problems? Because, as I said, it may sound very weird for the people who have not heard of this before, that if I redo an analysis, that a different number rolls out. How could that possibly happen? Well, unfortunately, we have some numbers that this does happen. So first of all, about these sort of visible reporting errors. In a previous research project with some of my colleagues, we found that 50% of psychology papers contain statistical reporting inconsistencies. So the type of things that you can already see in the text. Also in recent work, Tom Hardwick and I and a couple of other people found that in roughly 64% of psychology papers, we found different results upon reanalysis. And up to 63% of psychology authors admit to opportunistic use of flexibility in analysis, where you get sort of this garden of forking paths that was already been mentioned. So I would say that these are real problems that we really need to worry about. So again, why do I think that this sort of steps, this approach in steps makes sense? Well, first of all, because this reproducibility part, so steps 1, 2, 3, basically, is a prerequisite for replication. Because if you cannot verify these first steps, then what exactly are you replicating? If you find the same number as the original paper, you cannot really interpret it because the number in the first paper, wasn't correct. If you find a different number, you cannot really compare it. So the whole comparison part is sort of lost if you cannot assess reproducibility.
Michelle, if I may interrupt you briefly, 1 more minute?
Yeah. So the advantage of this procedure, I would argue, is that these steps sort of increase in the time it takes to perform them. So these visible errors, checking those, you can do that in less than an hour. And reanalyzing the data, maybe you can do that in a day. Sensitivity checks, maybe a week, but a replication can, in some cases, take over a year. So my advice would be to first make sure that the thing that you're trying to replicate made sense in the first place. Now, finally, I also think that this logic can also be used to improve your own work. If you're an original author, by making sure that you check the internal consistency of your reported results yourself, which is very easy to do, just the same way as that you would avoid typos in your own work. To share your raw data and analysis scripts, because without raw data, people cannot check the reproducibility of your paper, which means that we are left with a big question mark whether the numbers in your paper are correct or not. Third, you can also conduct and report your own sensitivity analyses. And finally, this is also an issue with replication research, that sometimes it's really hard to replicate something because it's very unclear what exactly had been done. So write detailed method sections and share your materials. So to sum up, with this 4-step robustness check, I think my main point is details matter. The numbers in your paper matter. And correct and robust numbers are basic requirements for scientific quality. And I would say that you can use this 4-step robustness check to both assess and improve robustness. So thank you very much.
Thank you so much, Michelle. This is amazing work. One thing, just for me to get clear on what you're up to, this is something that researchers can actually use when they're conducting their own studies before they publish the results, or is it something that you can only do on papers that are already published?
Both, I would say. So I think that this logic is useful for both, if I would call them original researchers and replicators, to put a sort of a label on it, because original researchers can use this logic to have sort of a clear framework in mind how they can improve the robustness and checkability of their own work. And I think that is useful because sometimes people have the best intentions, but there are so many advices and so many best practices that it's hard to it's easy to lose track. So I think that this could offer a structure in which to improve your own work. And I also think this is useful for people who intend to replicate a study, because if you are looking at a specific study and you already conclude that the numbers in the original paper make no sense, that you cannot sort of retrace the path of the original data to the reported number, then you might wonder, is it worth trying to replicate the study, or can I better spend my resources elsewhere?
Yeah, that makes sense. So just to be really clear on this, you're not trying to undermine Klaas's advice from before to involve statisticians in your research, right?
I think these two things can coexist.
Okay.
I think the main things that I'm aiming at sort of as an original researcher is to be structured in the way that you're sharing your information. So that could be both, sharing the results that you write up, sharing the data and the materials that underlie it, and reporting what you did in terms of sensitivity analyses. And for people who want to check another paper, ideally, you wouldn't need a statistician, because ideally the original authors wrote down what they did in terms of statistical analyses. So clearly that you would be able to refollow these steps.
Yeah.
But by all means, if you have a statistician on your team, involve them in this procedure.
Good. Yeah, I mean, ideally, we wouldn't need to be talking about research integrity also. But so a question from the audience, Jeroen de Ridder, he's asking, should the robustness checks really be centered around a p-value threshold of, say, 5%, or rather on effect sizes?
Very good question. I use the example of a p-value right now because this is the thing that most psychologists tend to focus on most. But the general logic behind these 4 steps can be applied to any statistic that is of interest to you. So if you are mainly interested in effect size and you try to reproduce the effect size by reanalyzing the data and you can't find it, and you find a completely different interpretation. So maybe the reported effect size was very large and you find an effect size that is very close to 0. That may also cast doubt on the validity of the original findings.
Yeah, good. So I want to say that we're getting some really positive feedback from the audience. So someone is commenting that this might actually be a very useful tool in grant award processes, where they can use this to check the quality of grant proposals. I think we're actually out of time, and perhaps a lot of us need a break. I know I do. So Michelle, thank you so much for contributing. It's great to hear about your work, and we'll talk more during the panel. Thanks.
Thank you very much.
So this brings us to the end of the first half of our symposium. Thanks everyone who's joining. We hope you'll be staying with us also during the second half. I think we're having, this is a great conversation we're having, some very excellent talks that we heard. Let us know how you're enjoying yourselves on Twitter, on Zoom, on the chat, and let us know if there's anything we can do to make the second half even better. So one final thing I should mention. We're taking a break, but if you're new to the topic of research integrity, we're going to show you a very brief video that tells you more about some of the issues that are involved in research integrity. It's only a 3-minute video, so you'll have another 10 minutes break time even after the video. So if you're interested, stick around, and we're going to be back with you at 10 minutes to 3.
Research affects us all. Every single day. From decisions about our health, to technological advancements in society, to helping us understand our biological, historical and cultural diversity, to modern-day engineering and astrophysics. Research is the foundation upon which our society is built. Trust that integrity is the bedrock of this foundation is crucial. Especially since new research is built on past work. While we strive to do our best as researchers, the challenges are many. Some unique to our field, others common to us all, including maintaining integrity in our research. Research integrity issues can be diverse and complex dilemmas: competition and work pressure, dependence on funding, unfair review of grant applications, inadequate reporting of study flaws and limitations, not publishing valid negative studies, insufficient mentoring and social support. It's a fine line between knowing the right thing and being able to do the right thing. We still know so little on exactly how often and why these issues occur. The current data just isn't enough. We need better data on these complex integrity issues. For that, we need you as a researcher to tell us what helps or hinders research integrity in your field. How? By joining our survey, the biggest ever on research integrity, funded by the Dutch government and targeted at improving the research environment across all universities in the Netherlands. Yours is an important voice we need to hear to set things moving in the right direction with the government and policymakers, for us as researchers, for us as a society, so research can continue to be the solid, trusted foundation of our world.
Welcome back, everyone. Let's get started with the second half of our symposium. I hope you're all still with us. Keep those questions coming in the Q&A, in the Zoom, and on Twitter. And don't forget to use our hashtag. And I also want to emphasize that we really want this conversation to be as broad as possible. So especially people from fields that we haven't heard so much about, keep your questions coming, ask them, and feel free to open the discussion and to broaden it in any way you see fit. It's my pleasure to introduce our next keynote speaker, the second keynote speaker of this event, Dr. Rosanne Herzberger. And let me make a small personal confession. I'm sort of a big fan. So her weekly contributions to NSA newspaper, I think, are really amazing. I mean, even if you don't agree with her, they're always well argued, they're provocative, they don't take cheap shots. So, I mean, Rosanne, if you had been here, I may have even asked for your autograph, but I'm not going to do that now. So beyond her accomplishments as a researcher, she is also a journalist, I mean, a regular contributor to NRC, but also the correspondent. And she is a microbiologist, of course, at the Vrije Universiteit Amsterdam. So I guess it's a pleasure to have you here. And oh, of course, I should mention the book, which has as the provocative subtitle, Why We Should Put Less Faith in Science. So, Rosanne, please take it away.
Thank you so much. That's a very flattering introduction for me. Now let's see if this can go smooth and everything. Did I unmute myself? Yes. Alrighty. Let's see if I can make this full screen. Right. Okay, well, hi everybody. Thank you so much for inviting me to give this talk amidst this prestigious lineup of speakers. Today's topic, the Research Integrity Survey, that was so elegantly and thoroughly designed by Lex Bouter and especially Gauri Gopalakrishna. It was a good reminder also about how different fields solve their problems. If there's a problem with integrity or organization of political debate, politicians generally solve that by hearing arguments from different sides and debating one another. If there's a problem with integrity in the courtrooms and the legal departments, they solve it by litigation and prosecution. And when there's a problem in the engineer department, they solve it by building new structures and algorithms and 3D printing. And when there's a problem in scientific research, our first reflex is to gather more data and do statistics. That's what we're good at, so that's what we do. Today, I want to talk about the societal context in which we do research and the consequences for integrity and the conflicts that arise, the conflicting interests at stake, and why I believe we have too much trust in research and how that's a problem for our integrity. But first, let me introduce myself. So my name is Rosanne Hertzberger. I studied life science and technology in Leiden and Delft, and I continued with my PhD at the University of Amsterdam as part of a collaboration with NISO Food Research, fully funded by the biggest food company in the world, Nestlé. So you can ask me lots of questions about research integrity. I'm a microbiologist, maybe a biochemist. I studied oxygen metabolism of lactic acid bacteria. And then I followed the bugs that had intrigued me so much, the lactobacilli, from fermented foods to the vaginal microbiome. So I flew to Missouri for a postdoc at Washington University in St. Louis, together with my husband and my cat. So here am I in the lab. My husband actually wrote a book about that time. I can really recommend it. Amerikanen lopen niet. But unfortunately, this episode ended up with a really ugly conflict between me and my supervisors. And in my Zomergasten episode of 2017, I compared it to a race yacht in full speed crashing on a coral reef. But it's not because of my scientific impact that you invited me here to speak. It's because of works like this book that you asked me. The work that had most impact in my career so far was my writing, my media performances. You know, I am one of those public academics appearing on talk shows. And so despite the fact that I have possibly accomplished least of all of you people listening to this virtual conference. But that's my role. I commentate, I opinionate, moderate, but most importantly, my weekly column in NRC Handelsblad, one of the Dutch national newspapers. When I came back to the Netherlands, the question was then what to do, because I knew that I could at that point make a living writing and speaking engagements. Yet the thought of leaving science and not doing the best job in the world, which is studying the chemical fundamentals of life, filled me with a tremendous amount of grief. And I thought that that was actually an unacceptable choice, to be in or out of science. So I chose to ignore the dilemma and just continue like I always did by doing both. So today I'm a guest researcher at the VU University Amsterdam, working at the Systems Biology Lab of Frank Bruggeman and Bas Teusing. I still study the vaginal lactic acid bacteria and their metabolism together with Professor Remco Kort. And I chose to do, or try to do at least, a form of radical transparent science. And I call that project RepLab, and I'm still exploring all the ups and downs. And I'm also finding out what it means to have my unconventional position of being both in and outside of academia. I've used my public presence to initiate the NL Wetenschap Twitter account. I just wanted to mention that. If you don't follow it yet, I can almost not imagine it. And I have many new wild plans, for instance, by starting something called the NL Wetenschapsfonds. So since I do a lot of paid work, I chose to give a yearly update of my conflicts of interest, and you can find that at Rosanne Hertzberger. And the yellow part is my column and media stuff, so that's about 1/3 of my income every year. So I see myself kind of suffering from a professional bipolar disorder. And this position allows me to switch freely between a media and a research perspective. And naturally, I exploit that to the fullest. So I have the privilege of being a scholar who views academia from the inside out as well as from the outside in. And I believe that the question of research integrity has to be addressed also by looking at scientific research from the outside in. Although a big part of the threat to integrity lies in the pretty boring topic of budgets and financial allocation, I do believe that another important threat for integrity in research comes from the position that scientific research holds in society as a whole, the expectations and the trust of the public, and the growing authority that researchers have in society. Lord Acton already knew all power tends to corrupt, and absolute power corrupts absolutely. Now, he never presented any data for this statement, or perhaps the people in power controlled the data that he could access, but let's hypothesize for a moment that there is some truth in this statement. Why would you then believe that scientific research is exempted from this? I think that scientific research is not excluded from this law. Hypothetical law, I must add. after all, science is a tool, a method whose outcomes completely depend on your intentions, what you put in. You can use science to generate knowledge, or you could use science to give credibility to your beliefs or your interest. And there's many examples of this. So let's say you're Emmanuel Charpentier. And you are in the lab and you see this weird Streptococcus thermophilus bacteria, and you ask, what is the role of those two weird pieces of RNA? And after a lot of experiments, you apply the scientific method. The answer is, well, it functions in a bacterial immune system called CRISPR-Cas9 that will change the world and also win you the Nobel Prize. It was awarded last week. I'm a big fan, so I had to include this. But let's say you're Coca-Cola. You can do, I think, good research practices as being Coca-Cola. And Coca-Cola subsidized extensively, actually, programs studying the effects of physical exercise for your health. So they asked the question, is physical exercise good for your health? And they applied a scientific method, probably pretty sound with statistics, kosher statistics and everything. And the answer is, well, yes, physical exercise is great for your health. Now, the complete answer is, of course, so is drinking less Coca-Cola. It's also very good for your health, but that doesn't come out of this great research work because that's not the question. Now, I do want to add that this is not a difference between academics and corporations. It's oftentimes vice versa. Corporations could be involved in very sound research. Some of the reproducibility problems in academic preclinical cancer biologies, I have to say, no, I think this is also reproducibility. No, this replicability. Why is this project even called reproducibility? After the previous talk, I'm all confused. But I mean, in this project, this was actually put on the map by corporations, like the biotech company, MTech. So they got pretty frustrated since academia was producing all these fancy schmancy Cell Nature science papers that would just not hold up when replicated in the Amgen labs. Just very practical, those results couldn't be used to make new cancer medicine. So in both examples that I just gave you, both Emmanuel Charpentier and Coca-Cola, the scientific method gave credibility to the results. But not in both cases this was justified. However, science is often viewed as this stamp of quality. I believe that's due to the public, society having too much trust in scientific research. We have a lot of trust in researchers, in the community, in the institutions, in the people, and in the results that we produce. So in my view, it has too much authority, too much power. And I see that as the most important driving forces that could negatively impact research integrity because of what Lord Acton says. So how could I possibly believe in this day and age that we have too much trust in science? Well, I agree, sometimes it doesn't look like it. According to some, we're moving towards a fact-free society. We're suffering from InfoWars, from conspiracy theorists, from viruswaanzin, or viruswaarheid, excuse me. And we currently see a true showdown of right and wrong in the American quabbles between Donald Trump and Dr. Fauci. Sometimes it doesn't seem like it when you see that Russian trolls and anti-vaxxers, or their male equivalent, the climate skeptics, are behind the 5G COVID conspiracy theory. And we love to focus on this too, I believe. We love these media stories, and the media loves it too. Because any disagreement, even a vote for a populist or a vote for Brexit, can be written off as due to misinformation. Cambridge Analytica, fake news on social media. If people would have just known the scientific truth, they would have voted differently. We love to believe this. So I think the influence of these groups are strongly exaggerated. Vaccination skeptics have been given a big megaphone with social media, and they love to use it, and we love to put them on the front page. I just want to remind you that the measles vaccination rate in this country has never dipped below 92%. We even worry about people who believe in a flat earth, for God's sake. And although they truly still exist, they are so rare that they wouldn't have been noticed without the help of the magnification glass called social media. So I do believe that social media is truly distorting the image of what's really going on. We worry a lot about trust of the public in data, in truth, in knowledge, in facts, but actually That worry itself is not very evidence-based. And, because you don't have to believe me, I will have to present some data, right? Because that's the only thing that we still believe. So another survey, a survey that went before the National Research Integrity Survey, and that is a survey by the Rathenau Institute that monitors trust of society in science. So what do we expect from our scientists? So on the left, you see like the rapportcijfer, the mark we give to each, let's say, societal institute, and how much we trust them. So as you see, scientific research is all the way on the left here. We trust researchers more than we do the judicial system, media, politicians, unions, government, big corporation. And that trust is not showing any signs of decline in the past years. So I actually believe that trust in science is so high, that is so high that we're currently seeing a new generation who loves to underpin their very random personal life choices by extrapolating scientific research. We see evidence-based education, evidence-based child rearing. One cannot go out and play a game of soccer. No, it's all about evidence-based exercise. There's evidence-based hobbies, evidence-based sleeping, evidence-based work environments, and especially at the dinner table, it's highly irresponsible to cook just from what you think is right without pulling out the latest nutritionist research. Science has to bear all this weight. We are putting a lot of weight and value in scientific judgment, although there's no such thing. A part of it is a good force. It's nice to have some research to make choices about risk, sustainability, sickness, and health. However, we forget that in most those choices, we, like our fathers and grandfathers, factor only a very small portion of what we choose. We like to think differently. People are still highly irrational creatures who choose on the basis of experience, of political orientation, zeitgeist, peer pressure, gut feeling, culture, intuition, religion, many other things. Very few people can be convinced by data to change their ways. I'm talking to a lot of psychologists here with my fellow speakers, so I'm kind of anxious to hear what they think about this. But we like to believe that we decide a lot on science, but most people only value the data from scientific research that support their choices and ignore the rest. So I'm just going to give you a recent example. The evidence for mouth protection in the Netherlands as an effective COVID measure. So we talked, in my view, way too long about scientific evidence for this. You even saw our own outbreak management team struggling with explaining why they didn't advise it. And I believe, they said it wasn't evidence-based. And other people, the red team, the other researchers said, well, they disagreed. They did think it was evidence-based. And I personally still get asked for my scientific opinion because media asks people like me for that, on the protection that these mouth caps provide. And, I won't give my scientific opinion. It's not my expertise, but I also think that scientific research is just not that important in this topic. This disagreement was never about facts. It was about culture. We hated mouth caps in the Netherlands from the get-go. I mean, in our country, we talk directly to one another. We don't hide. We not shumble or shy. We're pretty loud. We tell each other the truth. I mean, we keep our curtains open. Of course, we're going to bend the scientific literature as much as we could to conclude that mouth caps, and especially mandatory mouth caps, were unnecessary. Asians will overdo it. We will refuse it as long as we can. That's how the world works. Scientific literature on this measure is still highly, we would love to have more data on this. At the same time, you can put some question marks whether data are going to change anything because it's such a highly cultural, face coverings are such a highly cultural custom. Debates used to be divided along ideological or religious or cultural lines. We would agree to disagree, and then you can see your opponent, for instance, as, I'm going to skip this slide, as right-wing or left-wing, conservative versus progressive, individualist, and then your opponent could be more family-oriented. You could be a globalist, and then the person you're debating or you're disagreeing with can be a localist, religious, atheist, etc. This is in a world where we agree to disagree. But when we give facts and science more and more authority, is what you're getting in the debate is that you consider yourself as rational. The other person's not even coming from a different background. He's just plain irrational. You have the facts, they have fiction. You have news, they have fake news, etc., etc. And in the end, it means, and I think this is one of the fuels that makes debate so difficult nowadays, is that there's a right and a wrong instead of there's two sides of this thing. You even see the growing authority of knowledge and facts and science in our, allergy of conspiracy theorists. We give conspiracy theorists a tremendous amount of attention. And it's funny how we change the way we look at them. I mean, we used to be angry about Holocaust deniers because of their anti-Semitism. We used to hate people who want to use science to demonstrate that race is real and important because of their racism. That's what got us upset. Nowadays, we hate them because they're wrong, because they don't have their facts straight. That's scary. That's a perilous motion. It would have been much, much more honest if we would have accepted non-scientific arguments in this debate about mouth protections and say, you know what, face covering is 90% decided in the cultural realm, not in the scientific one. But when you don't accept the value of non-scientific arguments and don't even see those arguments and are not willing to communicate, even as researchers on the OMT, that you're influenced by your culture, for instance, you will never discuss the elephant in the room, your cultural background, and you will probably never understand each other. So this led me to write this short essay. You may call it a pamphlet. It was already last year, by the way, but I'm seeing it play out in real life sometimes. It appeared in Dutch. It's called The Big Nothing, because I got increasingly worried about the generation of leaders, of thinkers, of politicians, entrepreneurs, writers who don't see science merely as a tool to generate knowledge, but as some sort of an abstract authority, a source of wisdom, perhaps even replacing the Bible to judge over good and bad, although science doesn't generally do that. We still all, as humans, have fundamental questions on how to live our lives, how to design society, how to regulate. But in the West, in the Northern European West, we increasingly lack the ideology to answer those questions. Since 2018, the Netherlands is in majority atheist, agnostic, not part of a religious stream. So something is nowadays not just nice or pleasant or righteous or fair or morally right. Those are qualifications backed up by conviction and ideology and religion. Nowadays, we use qualifications like sustainable or safe or healthy according to evidence, and those can only be backed up by hard numbers. Those are measurable, stuff that we researchers need to provide, statistically significant, peer-reviewed, published in scientific journals. So I'll just switch gears a bit here.
1 or 2 more minutes?
I have 2 more minutes?
Yeah.
So there's some, I presented some evidence, let's say, that the information of the fact-free society is not as dire, and actually a new generation is, wants to be more educated. We see that one of the most important changes in society is the enormous increase in education levels. People yearn for lectures, for knowledge, for academic skills. Almost half of young people have a degree nowadays from university or from a college, University of Applied Sciences. And this is more than double compared to generations that are now aged 65 or 75 years old. So society is not exactly rejecting the values of academia, quite the opposite. So what should we teach them when they come to the university? So I believe it's one of our tasks to encourage them, the public, not to trust us more, but to trust us less, to be more skeptical, to ask more, not less critical questions, to scrutinize our methods and definitely our results. And one day, I really hope that when this Professor Dr. Clevers, a cancer biologist in the Netherlands, is attending a talk show like this, DWDD, it's not on the screen anymore, but another one perhaps. I hope that the host will not ask him only softball questions and ask him how awesome exactly his newest finding is and how many lives he will save, but ask him a real question, such as, so what's happening in preclinical cancer biology? Why are half of your studies not replicable? So let's go back to the beginning. I understand that people get worried by the sometimes low level of facts and sometimes completely fact-free politics of a new generation of populists. To the trust, but the people have a lot of trust in researchers. Almost 4 out of 5 people in the Netherlands think that researchers work cautiously. 2 out of 3 people in this country think that researchers work objectively, independently. Less than a quarter of people believe that researchers will change research methods to obtain the answers that they like, and those numbers haven't changed much compared to earlier surveys. So back to Lord Acton. Why do I believe that increased power and authority, trust, and impact of research in society affects research integrity? It's 2 ways. I think that 1, the more impact research has, not only literal impact factors in journals, but also the more prestige these results bear in society, the more incentive there is to engage in questionable research practices, but also vice versa. Perhaps we judge questionable research practices harsher. We think of them as more criminal when we expect more from research. Now, we can try long and hard to keep on increasing quality of research, but in case the public needs researchers to be holy and superhuman, it will never be enough. So, with great power comes great responsibility. That's why I'm so pleased with this initiative, doing a soul search in the Dutch research landscape. I'm looking forward to see the result. I hope it will allow us to have an honest conversation about what we can and cannot expect from research, that it doesn't only provide data, but also allows us to talk about our expectations, that researchers will never be these holy superhumans with no faults, instead like everyone else, deeply irrational subject of this species called Homo sapiens. And the only superpower the researchers have in the end is this tool in their hand, a method that can actually curtail their deepest human tendencies of making things up, but only when they decide to use it with the right intentions. I want to thank you for your attention, and let me know if you have any questions.
Thank you so much, Rosanne. That was, a huge prompt for us to do some soul searching, and we do appreciate it. So in the spirit of asking critical questions and particularly sort of talk show hosts and citizens asking critical questions, I wonder what your take is on citizen science and getting citizens more involved and sort of drawing them into science. Is that sort of something that you see as a way forward, also in regards to research integrity?
Yes. Yes, and I feel that research is getting more institutionalized. It's getting more difficult to do research, to publish your research. The standards for quality are increasing. Now you can't go without a methodologist. You can't go in biology. You can't go without a geneticist. You can't go without an ethicist. You can't go without yada yada yada. Now I do want to stress that I'm in the biology of the big effects. So I feel like in the molecular biology I'm involved in, I don't use cell culture, I don't use animal models. Like a gene has the effect and then we knock out the gene and the effect is gone. I don't feel like I need a statistician if there's a black or white effect.
Well, talk to Klaas. I mean, he might disagree.
Sorry?
Talk to Klaas because he might disagree.
He may disagree. Yeah. I can go back in line, stand in the methodology department. Perhaps I should. So I think that research should be for everybody. And if you see the tremendous amount of PhD people, PhDs we educate, independent researchers, and how many of them actually leave the research institutes to teach, to be doctors, to be, to do all sorts of valuable things. It is a very wasteful way of going about your human resources in science. So I think we should encourage everybody to be involved, to ask critical questions, to read, to keep on studying, and publishing.
Okay, good. So I have a bunch of questions from the audience that I want to ask you. So you mentioned that science should be looked at from the outside in, which is a very important point. But at the same time, it's pretty difficult for outsiders to actually do this, right? I mean, there's like maybe sort of intimidating people in white lab coats, but also, I mean, it's just hard. Science is hard. So how do you do that as someone from the outside, look into science in a reasonable and sensible way?
Well, if you see how many people we educate, so I'm going to go back to the previous point. It's not only PhDs, but also masters of science. I mean, we teach research skills at the universities of applied sciences, the HBOs of this country. I mean, we make a tremendous effort to educate people in studying, in doing research. So yeah, of course it's hard, but we also have a highly educated public that can read and that can think by themselves. And it's sometimes, to me, it's pretty almost arrogant from universities to say, no, sorry, please just listen to us. Don't read, don't study, don't do your own research. I get worried about that, because that's also, we shouldn't trust researchers. We should just, as journalists, as research journalists. Actually, Bernice Hausman has written an interesting book about that. It's called Antivax. And it describes how, for instance, research journalists used to, for instance, critically follow vaccine development. Nowadays, they don't, some of them follow vaccine development critically. Now they follow anti-vaxxers critically, and they try to defend the vaccine development. And I see a lot of those reflexes now saying, no, there's nothing wrong with the current vaccine development because science has to be always right. Where I actually appreciate it. It can be very annoying when people think for themselves and when people do their own research studies and people read themselves. But fact of the matter is that people are educated to do so. And, they were educated in academia mostly. But unfortunately, there's not a place for everybody in academia. So what do you do when you find yourself outside? Do you still get a permit to do research if you want to engage?
So
that's a question I had.
Let me sort of bounce that question back to you, because it seems like folks like Willem Engel at Virus Wahnsinn or Waarheid, he's doing a lot of thinking for himself, but the outcome might not be so wonderful.
Sure. Yeah, that's always the case. Even, if people will use tools, like I said, to do bad things and to, go for their own interest. That's both in university, that's in corporations, but that's also in the public. And I believe that he is critically addressed by academics, and you saw it also in the climate skeptics department, where Bert, now I lost his name, but there was one climate scientist. Every time these climate skeptics came up with a point, they just critically addressed him. They showed where he went wrong. And it doesn't mean that because there's people utilizing this for their own interest or for, with bad intentions, that we should not let people outside of a university engage in research.
Yeah. That's a completely fair point. So a question from the audience, Bart Penders. So he emphasizes that almost everything we know, we learned from others, right? I mean, there's not a whole lot of knowledge that we just produce entirely on our own. So when you're emphasizing that all of us need to be more critical and skeptical of science. So what exactly is it that you're asking us to be skeptical of? Is it the stance, the prestige, the authority of the Institute of Science or universities, or the scientists and researchers themselves? So what exactly, where's the skepticism supposed to be aimed at?
It can be all of them. I think the previous speaker, Michelle Nuit, has presented a beautiful tool to already critically follow, statistics, to check the GitHub algorithms, whether there's, loops in there, or not loops, but I mean, things where it goes wrong. You can follow what people do. And I think we do that in university and outside of university. Yeah, I don't know if that answers the question. Yeah.
I mean, it will have to do because we're out of time. Yeah, I'm sorry. So
well, there's still a panel.
There is still a panel. You're right. Yeah. So Rosanne, thanks so much for a very provocative and stimulating talk. Very happy to have you on this program today. And we will hear more from you during the panel. Thanks.
Yep.
Our final speaker is Professor Jeroen de Ridder. He was looking forward to being with us here today, but unfortunately he couldn't make it. Even not in his own, in front of his own computer. So his talk is pre-recorded. So Jeroen de Ridder is professor of translational neuroscience and head of department at the Anatomy and Neurosciences Department of the Amsterdam University Medical Centers. He is also the president of the Netherlands Organization for Health Research and Development, ZON-MW, and board member of the Netherlands Research Council, NWO. And I should also emphasize that he is one of my predecessors at the Young Academy. So please join me in watching his video presentation.
Hello everybody, great to be here today. Well, not in person, sorry about that, but still good to talk to you today about science integrity, which is a crucial subject, as I'm sure you'll agree. The recent situation with the corona pandemic has shown that there is great trust in science, which is good. The outbreak management team and the National Institute for Public Health and the Environment have advised the government on specific procedures to be followed to combat COVID, to prevent it spreading, and to ensure that our healthcare system can deal with the COVID cases. Trust in scientists and trust in science by society are essential for efficient progress and for reaping the full benefits of scientific results. Science is not merely an opinion. There is a certain danger in groups like viruswaarheid, or in groups opposing vaccination based on opinion and lure. In times of crisis especially, we have to be able to rely on science. But what makes science trustworthy? We all know stories where research integrity was sometimes severely breached. Major breaches like fabrication of data and modification of results or conclusions to fit the researcher's hypothesis better are fortunately relatively uncommon. But there is a gray area where many of us, if not all, dwell on a nearly daily basis. We cite who we know or trust, who we like even. We may report that which we understand best and leave out what does not fit our expectation, not because we want to be dishonest, but because we have too little time or because we believe we are right in our assumptions. Maybe we feel that our own work deserves that extra bit of attention. And that's why we self-cite at the cost of a more thorough review of the literature. It may be tempting to many a researcher to sweep some of the study's most difficult shortcomings under the carpet. Several of these temptations, bigger or smaller, will meet us on our paths on a daily basis. And that is why we need to be conscious of them and discuss them amongst each other. Without too much judgment or fear, that is. A discussion like that needs to become part and parcel of normal scientific practice. NWO and ZON-MW can and should help researchers steer clear of research integrity temptations. We ask our applicants to adhere to the National Code of Conduct for Research Integrity. We ask this because, and I'm reading literally now from the text of the code, we believe that non-compliance with them undermines professional responsibility, which harms the research process and the relationship between individual researchers, and possibly also trust in and the credibility of the research. The code describes 5 widely supported principles. The first is independence, the second transparency, the third honesty, the fourth, scrupulousness, and the fifth, responsibility, and it elaborates into more specific standards for good research practices. The code is our guideline, based on which a discussion on good research practice can take place. But that is not all the funders have and do. Apart from adhering to the code of conduct, we actually investigate what research integrity entails. In 2016, for example, Zonneweg and NWO launched the Fostering Responsible Research Practices program. With this Research on Research program, we wanted to give off a strong signal that we have to invest in systematic reflection as part of our science system. The program has, amongst other things, focused on gaining empirical knowledge on responsible and questionable research practices, on finding best and worst practices, and has used also this knowledge to develop interventions. Let's have a look at a few results of this innovative Research on Research program. First, responsible journals. One of our funded projects focused on responsible editorial policies. A platform was set up, the so-called Platform for Responsible Editorial Policies, PREP, which is a bit of an unfortunate name. PREP facilitates journal editors to be more transparent about their editorial procedures. The platform advises journal editors and publishers on potential improvements of their peer review procedures and presents integrated information about the variety of review procedures currently in use. An editor myself, I can tell you that subconsciously, the a priori impression of a research group or theme can determine what reviewers are chosen by me. If editors are asked to explicate their choice of reviewers better, this bias might just disappear. The platform PREP also maintains a database of journals' current peer review formats and provides information and tools for journals to use journal metrics in a responsible way. A second project is competitive research funding versus questionable research practices. Competitive research funding, Zonneweg and NWO's raison d'être, can certainly have positive effects on science, but there are also problematic effects. Competition for research finance can lead to poor relevance and quality of research, short horizons, ineffective collaborations, low-risk sure-thing research. In an attempt to maximize their chances of obtaining funding, researchers will make their ideas subject to calls and check the boxes. And having to pour our ideas into projects of 2, 3, or 4 years makes us forget about the bigger picture. We call this projectification, not to speak about the administrative load of writing new grants every few years. We work inefficiently and we are overly forced to think that good science can be forced into small units of time and effort. Sometimes science needs a bit of air. Lastly, the myth of the null hypothesis, another project from our Fostering Responsible Research Practices program. Statistical testing of null hypothesis is a daily routine for many researchers. Researchers are often insufficiently aware that this does not allow them to draw conclusions about their data in a direct, but only in an indirect way. As a result, conclusions from scientific research are regularly incorrect. Methodologists have pointed this out for years. Nevertheless, testing null hypothesis remains popular, while a number of perhaps better alternatives are available. In a highly interesting Fostering Responsible Research Practices study, interviews and focus groups were used to investigate why many researchers stick to testing null hypotheses and what disadvantages they see in alternative methods. The aim was to identify which researchers want to be pioneers in promoting the use of better alternative methods. Together with them, a strategy will be implemented for a better use of these alternatives in scientific research. As many of these projects show, research integrity is not some box you tick. It is not something you check after research has been done. It is a deeply rooted and internally lived disposition that is part of the modern scientist. In the Netherlands, several converging agendas, open science, science in transition, and a less organized call to action from mostly the younger generations of scientists led to a position paper on what should be the rewards and incentives of working in academia. For example, instead of working solistically and trying to win that one Nobel Prize for yourself, more emphasis was put on the value of team science. That is, on working together, forming consortia, building bridges between disciplines. After all, great problems often asked for interdisciplinary solutions. Also, the report stipulated that those wishing to combine research and education should be facilitated better to do so. They should be valued for doing so. Finally, working towards open science was deemed of central importance in the report. It is a disposition, a mindset. Working towards open science means thinking differently all along the way of conducting your research. And although it wasn't part of the committee's initial reports on the new rewards and incentives program, I believe a follow-up report should equally include research integrity as one of the elemental factors based on which a scientist should be rewarded and incentivized. Investigating research integrity, or even just making it available for an open discussion, should be one of the central tasks of a responsible academician. At least that's how I feel. Research integrity is like open science in that perspective. It should enter the DNA of the researcher. He or she should consistently reflect on questions of integrity. Students should be taught, and research groups should put the topic on their agenda. I have a research group, an active one. We publish, we present, but we almost never question how we do it. Why is that? Why do we choose to show some results but not others? Why do we emphasize certain things in our discussions of papers? Why do we use a t-test for our statistics but don't look for potentially better tests? Because it takes too much time? Why am I senior author on many papers? Should my associate not get the credit, for example? These and other questions should be an integral part of your agenda and your interpersonal discussions as a researcher. Research integrity should not be something you fear as a subject, but it should be something you look forward to. A philosophical reflection that makes your practice better. It should open discussion, not close it. A mirror for yourself and others. That's what research integrity should be. We all encounter situations where questions about integrity arise. Talking about research integrity should not be punishment or fear thereof, but it should be a reward. Thank you very much.
Thank you, Jeroen Geurts. He's not with us, but I will pay the thanks forward to him. So that brings us to the panel, and this may well be the most challenging part of today, to manage an online panel well. So we'll see how that goes. So welcome back to all our panelists. Good to have you with us here on the screen again. I'm actually blocking someone's view, maybe. Sorry, Roeline, this is terrible. Yeah, what can we do about this? Get me out of the screen, maybe. Anyway, so I'm going to ask you a few questions. If you want to respond to something that one of the other panelists is saying, please raise your hand. I can actually see you, so that should work. So I'm going to try and move a little bit out of the way, maybe, so Roeline is at least somewhat visible.
I'm fine with it.
Oh, okay. So I'm getting a note from the tech people that there is actually an alternative. So I'm going to move to another location, and we'll be with you in a second. And I'm back. Or am I? I am back. Good. This is amazing. So if you have a question or a remark, something you want to say to one of the other panelists, please raise your hand. So I want to kick off this panel. Oh, I forgot the iPad on which the questions, is someone going to, yeah, that'd be great. Oh, all right, here we go. So let's talk about open science, fast science, and the COVID pandemic. So I wonder what your take is on that. Do you feel, because I mean, over the past months, we've seen a lot of open science, I guess. Did you feel that has been a good thing, sort of open science in combination with fast science? Any thoughts on this? Any thoughts on this? I'm sorry, maybe from Klaas first.
Well, actually, I saw Michelle raising her hand first, so I propose to go to her first, if you don't mind.
Okay, let's do Michelle first. There's a whole situation here with different screens, but I will be okay in the end. So, Michelle, apologies.
No worries. Thanks, Klaas. I was just triggered immediately because this is a project that, together with several colleagues, I'm actually working on right now, because it's a very important question. This COVID science is very, sort of special in a way that it's really fast. We need answers really quickly, and it's very promising to see the speed with which the scientific community has reacted to this crisis. But we also need to be very careful that with this speed, we don't cut corners. And I think the important part of this is that it's an empirical question, whether or not we are cutting corners and what the quality of this type of research is.
So are you saying it's too soon to tell, maybe? Because it's an empirical question, we don't know yet whether this is a good thing?
So I'm actually in the process of collecting data on this right now, in which we are comparing the number of statistical errors in COVID papers and non-COVID papers to answer this question exactly. So I think my suspicion is that the error rates will be higher in the COVID papers because there's so much pressure to get it out quickly, and we're all humans, as I think is the sort of the theme of today. So yeah, I think there is a risk, but I also think it's important to collect data on this to answer this question.
Yeah. So Klaas, over to you.
I really don't mind the speed of working, as long as you don't forget to replicate in the end.
Daniel? Maybe
Sorry, I wrote a column in Nature about this like 2 months ago, I think, where I propose that people have a sort of red team, like the government has a red team. And I think it would be very useful because we're going to bypass the peer review process to a certain extent when we publish. That takes pretty long in most cases. So people should try to internalize this criticism before they publish this preprint and get sort of criticism along the way from people. And that's a way to have some quality control, but still have this preprint system, for example.
All right, good. Rosanna, what do you think about this?
Difficult. I don't really know. I think that it's rare in history that we had so much scientific effort going to one virus. So everybody's studying the exact same virus, and that's. I think, I would be really interested to see Michelle's data on this, because I think that's a beautiful natural experiment we're doing. I am wondering if you need real replication studies all the time. I mean, if you find in different, I always find it more strong, especially if you see, let's say, the weaknesses of cell culture in animal models. I find it always stronger if there's a slight difference in methodology in finding the same robust effects. I mean, let's talk, if you look at insulin, for instance, insulin lowering blood glucose. I mean, that's going to be true regardless of the different animal models, regardless of the different setups. Those are big, important, robust effects. And the smaller the effect, I think, the more robust your replication and thorough your replication must be. So somehow I think that we're still learning, although perhaps we don't really take the time to replicate exactly each other's studies.
Yeah. Okay, that's good. So I want to try and broaden our conversation a little bit to talk more about qualitative research and also the humanities. So we've heard a bit from Roeline about this. I wonder, maybe the other panelists can comment on to what extent they think that the stuff about research integrity and the methods they've been talking about have application in fields where mostly qualitative research is used, or interpretive methods. And when we're studying literature, I mean, presumably there are questions about integrity as well. So any thoughts on this from our panelists? Daniel.
So I think for a large part, the goal is to allow other people to evaluate the quality of your work. And in qualitative research, there are always points of discussion. So what you want to make possible is that other people think along and develop their own viewpoints about this. And by creating more openness in the process, you allow other people to do this. So I would say that that's a benefit. And in the end, it should prevent people from having sort of one-sided conclusions from qualitative work as well, if we open up the process a bit more, I would hope.
Yeah, Bert? Bert? Oh, did we lose Bert? No, there you are.
Yeah, and maybe some specific, just remember from other, I know at Yale they have an institute where they're trying to, for instance, make it possible for historians to cite old texts and make very specific which part of a text you're citing from, or to actually link to the documents. I think in sort of the qualitative work that I see in the social sciences, you can think of your interview scheme, if you work with that, or whom are you going to interview. You can make it transparent at the start of the study or when you're updating the decisions you're making. So I think some of these decisions can be made public for other people.
Yeah, that makes a lot of sense. Roeline, do you want to comment on this?
But I agree with that, because that was also one of the things I mentioned myself, that transparency is also in qualitative research, I think one of the important things. But coming back to open science and qualitative research and the replication, that's difficult for qualitative research, and also to give raw data to others is difficult because of privacy issues, for instance. When you have an interview and you give the raw transcript, then you can't guarantee privacy. But what you can do on a more aggregated level, you can show your data and indeed give as much as detail what your thoughts and what your decisions were along the way. Then you can make it more visible and also more retractable, and maybe also more reproduce. What was it? Reproducible. So I think there are possibilities.
Yeah. So I wonder, maybe Klaas, can you share something about an institutional perspective on this? I mean, as a rector, I'm sure you hear from different faculties and departments. So what about the humanities and some of the social sciences? Are they sort of on board with this discussion about research integrity, or is there more that needs to be done to make them part of this conversation?
I think they're a little behind. That's my impression, and that's not their fault so much, but that is mostly because for the past couple of years, attention has been focused on quantitative research, numerical data sets, and not qualitative research. But for example, from our School of Humanities and Digital Science, there's a lot of interest now in also having this discussion among people who do research based on documents, for example, document analysis. And I think there are a couple of differences and a couple of similarities. We have to think about those very much. So this is all at the start of the process, I think. But I was glad to hear many people suggest that what will help the humanities also is to publish your data as much as you can, and no matter how they look like. I mean, it can mean publishing documents and whatever kind of sources, data sources you use. And of course, you will run into problems there. Nothing is perfect. So sometimes the data, you don't own the data. They're not, you don't own them. So you can't decide whether you can publish them. That means you have to negotiate with the owner of the data. And the other thing is privacy. Indeed, privacy can be a big problem. And well, I don't know how, I don't have a ready-made answer to that, but well, clearly, I'm glad qualitative research is also on board. Let me put it that way.
Yeah. I mean, I wonder if it's fair to say that this issue of privacy is sort of an inherent limit, because I mean, when we are working with private stories or sort of personal interpretations or just long form interviews, I mean, it's really hard to anonymize that data. So there might be a barrier to sharing it with other researchers. I think, that's sort of an inevitable worry. Or do you see any ways around this worry?
I think you're right. But at the same time, I think it's so important to have those perspectives too. So for a bit, we have to buy with it. But what I said, when you bring it a bit more on the aggregated level, or you can anonymize your data, and sometimes you can mix it a bit, but still the outcome is the same, then it's possible. So, but I also, yes, with some points we have to buy with it, I think.
Daniel, did you want to speak to this?
Yeah, another approach might be what the UK Biobank does. So they keep guard of all the data, and you can send an analysis script, and they will run an analysis and send the results back to you. So the data is kept very safe in one place, but people can still use it. It would, of course, require a lot of coordination, but for valuable data, that might be interesting.
Yeah, that's a really interesting suggestion. Michelle, do you want to comment on this too?
Yeah, that was pretty much the way I was also looking at that. There might be something in between, like not sharing your data or sharing everything completely openly, because in the end, what I would think is very important, at least that your conclusions are verifiable by an independent party, but there might be ways to deal with that without having everything openly online.
Yeah, good. So I'm actually curious about some of the other panelists' responses to what Rosanna has been saying. I mean, do you agree that we put too much trust in science, or how would you respond to some of her comments?
Can I just quickly respond still to the qualitative research
Yes,
question?
of course. Yeah, sorry, I missed you.
To just say something other completely insane remark in this such a neat panel. Qualitative research is qualitative because it's not quantitative. There's a reason, there's a value in studying things that do not fit in boxes and that you can't put a number on, or it's really hard to put a number on. And nowadays we love data and statistics and methods and rigor so much that we have a hammer and we want everybody to be a nil. And a lot of the value in qualitative research, I feel, gets lost if we just judge them and judge qualitative research by, trying to put them in a box where they don't fit. And there's so many studies. I mean, even in microbiology, we barely do real exploration with microscopy anymore, because how do you draw a new life form? You're not going to be able to. A drawing doesn't count. If you can put a number on it. But also, big HIV studies just completely failed because the participants were over and over saying that these pills were, there was a big stigma on taking the pills. And that's why a few months later, they found out that actually the participants hadn't been taking the pills. If we would have allowed more qualitative research, we would have already known that people were not taking the pills because this was highly stigmatic. There's many instances I feel that we're missing qualitative research, and would be really a pity if it gets lost because of the standards.
Yeah. I think that's a very important point. But we want qualitative research for sure. And as a philosopher, I can only sort of underline this. But we also want really good qualitative research, right? Qualitative research that replicates or is reproducible. And I guess sort of the concern that we're talking about is, well, how do we accomplish that? We don't want just more qualitative research if it's bad quality stuff.
Sure, but that counts for everybody. That counts for preclinical cancer biology, that counts for big data, that counts for corporations doing science. Just the fact that there are people abusing the authority that scientific research gives to promote their own interests doesn't mean that those research practices or research the methods they've been using need to be discredited. Just like people outside of universities don't need to be all bad because there's a few bad examples. Just like the people in university. There's a lot of bad examples, and if there's really for qualitative research, I think that doesn't mean that the whole bunch is not that the value of the whole bunch is not important.
Yeah, that's good. So there's an interesting observation from someone in the audience, and he points at a paradox, or perhaps maybe it's not a paradox, maybe it's even a contradiction, but he notes that when it comes to research evaluation, we're sort of moving away from quantitative evaluations, right? H indices, impact factors, we don't want those anymore, or at least a lot of people don't. But at the same time, when it comes to research integrity, at least today, we've been going very quantitative. Only just now if we start talking about research integrity and qualitative research, and of course, Roeline's talk before. So do you see a tension there? So when it comes to evaluation, we're moving away from quantitative, and when it comes to doing science and research integrity, we want more quantitative? Is that is there anything wrong with that?
Is this for Roeline or for me?
It's for anyone who wants to share their thoughts.
It's a very difficult question. I'm going to keep.
I know. I'm sorry. Daniel, do you want to share your thoughts?
I think historically what we've been working on is fixing the easy things first. And very often those are quantitative because we know you shouldn't p-hack and we know what the consequences are. We can simulate it. But what you see in the discussions is that moving up to what is a good theory? What's a good theoretical prediction? And by the time we reach that question, I don't think we can quantify that easily. So then we'll move into this more subjective discussion, like, well, what makes a good theory? There are different opinions about it. But I think now it's so quantitative, not because we think that's the only thing that matters, but because it's the easiest thing to fix.
Yeah, so we're just going for the low-hanging fruit, is what you're saying. Yeah. Klaas, do you have thoughts on this?
Well, I agree with Daniel. I think we can do both. I think there is not a lot wrong with looking at age indices. I mean, it simply shows how often your work is cited in a way. Or you could look at the number of citations. Well, if you want to do things that matter, you want to be read. I mean, I think that's self-evident. I don't see a problem there. But what I think is important and what we seem to have forgotten over the past few decades is that there is also a question of what the quality of the work is. And that is a non-quantitative question, so to speak. But let's not kid ourselves. The assessment of the quality of your work, is not only subjective, but also very difficult. Because you have to ask questions like, what are the main themes in a particular research area? Are you contributing to the solution of questions that arise within these main themes? If not, what's the problem? Is it because your research isn't very effective, whatever, and so on and so on. If you're doing other things, why are you doing other things? I mean, may not sound completely reasonable from the perspective we use now, but we have to dig into qualitative questions like that in order to be able to say something about the quality of what we're doing. And well, that may not be that easy, but well, let's look at the bright side. We're all bright people, so I'm sure we'll come up with a solution. But I don't know which one that will be.
Sure, yeah. Yeah, that's a very illuminating remark you made just there, or at least illuminating to me. So when it comes to evaluating research, we are asking qualitative questions. And of course, in lots of actual research, we're asking quantitative questions. So we just need to we need to use the methods that fit our questions. That makes perfect sense. I want to try and circle back to the question I wanted to ask before about responses to Rosanne's talk from other panelists. Anyone who felt provoked by what some of the things she said? Bert?
Maybe give it a slightly different angle, but I think we should not take trust for granted. In a sense that thinking about research practices, if we're just in a discipline telling stories to each other, then maybe how we do our research might not be all that important. But we all want to go out into the world and give advice on whether it's COVID, whether it's whatever field you're in. And if that's the case, I think the tension that Rosanne is rising is that like people, we see it with COVID, but anybody with a social media account can build a platform where he or she can create a follower base and have a discussion about things. And for scientists to be a part of that discussion in 21st century, I think we need to have our own shop in order, and that means to be open and reproducible. It means that sometimes replications fail. That's not what I'm saying, but it should at least all be transparent what we're doing and to the highest rigorous standards. And I think that if we do that, then we can also have, then I'm not so worried about whatever will happen in the 21st century. If we don't do this, I think we're facing the critique, and you see this in other countries as well, where certain politicians turn towards elites, which are also the academic elite. Yeah, and maybe rightfully so. If we don't have our practices in order, then we're also very vulnerable to that critique. So it's not really, I don't think Rosanne and I per se disagree, but I think this is how I've been thinking about it a little bit along the lines of your talk, Rosanne.
Yeah. So Daniel, you were nodding in agreement. Were you agreeing with everything Bert said, or do you want to add something of your own?
Well, I think one of the nice points that Rosanne made was this opposition between science being good or science being bad. And I think the challenge is to figure out which science to trust. The question is not, can you trust science or can't you trust science, but it's which science you can trust. And in that sense, Bert's talk was, I think, very nice, where he trusted something in the beginning and he was already a trained scientist and everything. And then now he's realized, looking back, maybe I shouldn't have trusted this much. So that shows how difficult it is to learn which scientific findings you can trust and which not. So it's very difficult, and educating the general public about which science you can trust and which you can't is going to be really difficult, I think. I would love to not have it polarized as much, as Rosanne mentioned. I am not completely sure how we can get there, but yeah.
Yeah, this what you said just reminds me of a comment by the British philosopher Baroness Honora O'Neill in a talk about trust in society. So she said, people sometimes say we need more trust in society, and to her that just seemed like a very weird and wrong-headed claim, because we don't just need more trust in general, we need well-placed trust. And I think that's really key here. You don't need to sort of start, trusting people and scientists randomly. No, you need to figure out whom to trust, and then the people that you can trust, actually do trust them. But of course not trust the people that you can't trust, or the science papers or what have you. Is that helpful to you, Rosanne, or are you unconvinced?
Yeah, it's difficult. There's whole fields currently in academia that I think shouldn't be trusted, but are getting a lot of trust. I'm only talking about mindfulness. Oxford's mindfulness center, where there's all the big people in the field actually have started studying mindfulness from a background of being like a Buddhist monk or a Tibetan monk or a yogi or a mindfulness teacher even. With the prejudice that they weren't asking, like, what does mindfulness do to the body and the mind, but why is mindfulness such a great idea? These people, they continue, getting publishing and researching from a very specific angle. Let's say, perhaps Bert is a great example before you found out that your premises were actually not true. But these people were never. They don't show this insight. And what I think is important for people to know, and perhaps a survey can help this, is that a lot of researchers themselves are highly irrational. They have a complete interest in their outcomes, especially, their career depends on it, their livelihood depends on it, their next grant depends on it, their contracts. So they have an increasing incentive to, have awesome research outcomes. I don't know if the public knows this. Sometimes I believe it won't even, the outcomes won't even change the level of trust we have in society or in research. But normally the subtitle of my book, Why We Have Too Much Trust in Society or in Research, is very negatively perceived. Well, did it change your mind at all? Did you start to think differently, or were you already on board? The public has responded pretty negatively to this statement.
Yeah. So, a final thing.
Can I ask the other panelists?
Oh, yeah, you can, I think. You just did. Klaas.
Well, I think it's a good idea. It's always a good idea. It's always been a good idea to be responsive to what non-scientists say about what we do. It's always there's a very practical reason. They pay our salaries, right? So let's be responsive. And of course, many good ideas may come out of that. At least, anyway, many critical questions come out of it and make you think. And that's at least is valuable, I think. On the other hand, I think we should also allow ourselves to be critical of what non-scientists say of us, of their opinions, and what they think is the right thing to do. So as long as the criticism goes both ways, I'm very much in favor of it.
Yeah. So I want to try and tie this question about trust in with the previous discussion we had about the humanities and qualitative research. Because in my experience, I mean, when it comes to trust, qualitative research and the humanities are usually pretty low on the ladder. So I wonder, is that your experience too, Roeline? And is there something that we can do about this or ought to do?
Yes, that is my experience in part, because it's often said, well, qualitative research is subjective, it's just an opinion, it's just a story. And I hope what I presented today showed that what you can do as a qualitative researcher to go against it and to really show what qualitative research is and what the safeguards are. And then you can hopefully more trust it. On the other hand, when you look at which questions are answered, and there was often a discussion between quantitative research and qualitative researchers, and we've seen today a lot of examples that quantitative research isn't that exact as we always think it is, or we might think it is. Qualitative research might be sometimes have more validity because you go very in depth and you have insights. So it might be more valid. But I think it's a bit of a not so nice discussion because I don't want to polarize qualitative and quantitative research. But yeah.
Yeah, no,
I think it's up to ourselves to be trusted, to be transparent, and to be honest about your own thoughts and about your own flaws in your research. I think that's the most important thing.
Yeah, that's a very, very worthwhile comment. So it's almost time to wrap up this panel, but I want to do that by asking all of you to answer a question that I'm going to ask in 1 or 2 sentences. So please be brief. And it is this question. If you can give a piece of advice to someone who's just starting in this area of research integrity, became interested because of this symposium or was interested all along, what is the single most important thing that you can start doing as a researcher or maybe as a policymaker or even a funder? I mean, we have different audiences here with us. So I'm going to start with Michelle.
Yeah, very good question. I think, this is off the top of my head, but the first thing that pops up in my mind is the advice that I would give is to first start out with what works for you and your situation, because there are so many practices that we are proposing to improve our science that it can be overwhelming. My advice would be just cherry pick one good practice that sort of resonates with you and build up from there.
All right, just do it, I guess. Thanks. Klaas.
I would say never be embarrassed to make mistakes, but always be prepared to correct them.
All right, thank you. Roeline?
Sorry, I can add to that, be reflexive. Really look into yourself and be honest to yourself.
That's great. Yeah. Daniel?
I would recommend to follow your principles. I think we pretty much intuitively know what good science is supposed to look like, and you shouldn't be convinced by your peers or supervisors that that's not how it looks like. That is just what you're supposed to do.
All right. You have an optimistic view of researchers. I like that. Bert?
I would say the situation can look that institutions or universities are pushing you to do certain things, but maybe actually do it from an own motivation. Your own research will get better and will be more fun to do work, academic work.
All right, thanks. Rosanne, final word. No pressure.
Yeah, so study big effects. Find something massive, like unmissable. So you don't need like too many statistics and trying meddling, but it's completely obvious what's going on, and make sure early on to check whether other people are also finding that this effect is massive, because that guarantees a really great PhD, a really great research project. And don't get dragged away by impact and by machos and by big labs.
All right, thank you. I'm tempted to say that's easy for you to say as a microbiologist, but I'm going to leave it at that. Thank you all. Thanks to all panelists for a very stimulating discussion. I feel like this has been really helpful in trying to broaden the agenda and get some actual practical advice. So thanks, everyone. A warm round of applause virtually. All right, I'm back at my table. So the last thing on our program is certainly not the least thing. We are going to launch the National Survey on Research Integrity now. And with us here today to do that is our final speaker. We've heard about her today, Gauri. I'm so sorry, I mess up your name. This is so embarrassing. Gauri, I'm just going to leave it at that. It's a pleasure to have you with us today. I'm so sorry. She's an epidemiologist with a lot of experience in public and private health policy, and she was very actively involved in the containment of the SARS outbreak in Singapore in 2003. So I'm sort of happy to learn that she is on our national COVID-19 red team. We need to listen to her and pay attention. So she's been incredibly busy with setting up this research integrity survey and our symposium this afternoon. You would not believe the number of emails I have from her in my inbox. So happy to have you here, Gauri. You are on the team. There's also Lex Bouter. There's a number of other people who are involved with this, but I'm going to hand it over to you.
So just getting set up here. I guess you can all hear me. It's a bit of a weird situation where I can't really actually see anyone nodding, so I suppose you can hear me well. Yeah, okay, great. So thank you so much, Jeroen, for accepting this rather challenging challenge that we set forth to you. Thank you everyone who's joining us online and who's staying on in this very long, but personally for me, fruitful and invigorating afternoon. I would like to start by sharing with you some impressions I've had in the recent times, in the last 6 to 8 months, some themes also that have been discussed today. Words such as disinformation, misinformation, speed science, sloppy science, can we trust science is something we have discussed extensively this afternoon, and also something that has come back repeatedly, particularly since March this year. Science has been, whether we like it or not, for better or worse, front and center in our lives these last couple of months, and probably in the future. Today, we heard from several speakers on ways in which we can improve the robustness of our research methods. But to concretely solve a problem, the group that I work with, and hopefully you will agree with me, we first need to concretely understand the problem in order to be able to produce and introduce sustainable solutions. One of the main challenges that we face in academic research is trying to obtain comprehensive national data that addresses a wide range of explanatory factors around research misbehaviors, questionable research practices, and responsible research conduct, but also data that is comprehensive towards different disciplinary fields. And that is basically what the Dutch National Survey on Research Integrity is aiming to do. So research integrity, if I can summarize that in a short phrase, basically can be defined as standards that can influence or impact research behaviors. And some of our speakers have actually touched on some of these professional standards, as you've heard from Klaas and Jeroen Kertz, the Dutch Code of Conduct on Research Integrity, which was launched in 2018, shortly just right after the European Code on the same in 2017, the World Conferences on Research Integrity, which enters its 7th year in 2022. These are all efforts which have been targeted with the mission and the goal to foster discussion and an exchange between different disciplines and diverse opinions to improve the way in which we conduct, reward, and recognize research. The Dutch National Survey on Research Integrity aims to exactly build on this discussion by addressing two main goals. One is to concretely generate some national estimates across different disciplinary fields on responsible research practices, questionable research practices, and research misbehaviors. We would also like to understand what are some of these causative factors or explanatory variables or determinants, as we call them, that might be associated with some of these practices across these different disciplines. Determinants that are familiar to all of us as researchers, such as individual and peer norms that we've talked about, mentoring and social support, work and publication pressure, our dependence on funding, organizational justice, which includes allocation of tasks, fair promotional assessments, and so on. So the number of determinants that we are aiming to look at in this survey are large and they are broad. These determinants have been chosen based on an extensive literature review, but also ones that we hope will be actionable at the grassroots level, at the institutional level. That, in essence, is the National Survey on Research Integrity. It's the single largest survey to date targeting the largest academic population in the Netherlands. It will be launched throughout all universities and university medical centers as we speak today in the Netherlands, across all different disciplinary fields, because we want to open the dialogue not just with the biomedical sciences and the life sciences, but we also want to engage the humanities, social sciences, natural and engineering researchers. We will be addressing PhDs to full professors because we believe that there are differences in the behaviors and practices and the explanatory variables that influence these choices. There have, of course, been other surveys on research integrity that have been conducted, but none as large and as ambitious as the Dutch National Survey. What the National Survey on Research Integrity is not is a ranking exercise of any kind. We do not collect any institutional level data, and it is also not our goal to rank any individuals or institutions. And we do this by protecting privacy. This is topmost in the design of this survey, and we have attempted to address this in a number of different ways. The first one is by using a trusted third-party, Kantar Public, who will be conducting this online survey, and you will be receiving invitational emails from our trusted third party to all academics in the Netherlands. They store no IP addresses, basically meaning that once a completed survey has been sent, there is no possible way to trace it back to its respondent. As the research team, we will receive only fully anonymized datasets. And for the most sensitive behavioral questions on research misbehaviors, we have introduced a methodology called the randomized response method. This is a method that has been extensively studied and been around since the 1950s and proven to elicit more honest answers the more sensitive the questions are. It's been used in areas to study doping in sports medicine, for instance. I unfortunately, in the interest of time, do not want to go into the methodology behind this instrument, this device. I would urge you instead to look at our website where we have tried to explain this in a short and succinct manner, how it protects your privacy when you are answering a sensitive question, particularly around research misbehaviors. What do we hope to do with the results from this national survey? We intend to actually do some primary analysis looking at differences but also similarities between the different disciplinary fields, academic ranks, and what might be some of the possible explanatory reasons or determinants for some of these choices. We also try our best to walk our talk. And so all our protocols have been pre-registered, and we hope to be able to share with you first results of this nationwide study at the end of Q2 in next year. It's been a long journey, 2.5 years only, to reach this milestone today. We've done extensive pilot testing, a large number of focus groups across a wide range of disciplines. We have tested and retested the survey instrument. So I'm happy to actually report to the panel and to everyone who's joining us that this is a mixed method study that I am proud of. The survey methodology underpins it, but we have done extensive discussions in focus group interviews, as well as pilot testing wordings, the use of particular words, so that all disciplines feel as included as possible in this survey. I would like to give thanks actually to the core research team on the national survey, whose names you see up here, including our engaging steering committee, to name a few. and you as the researchers. Your voice matters to us, and it is your views that we hope we will be able to hear. And on that note, I would like to end by allowing some of my own fellow researchers to speak for themselves on why they will be joining the National Survey on Research Integrity. With this, I would like to kick off the start of the Dutch National Survey. Of course, this data alone doesn't tell us the complete story, as we have discussed, but we believe it is a firm and concrete start to trying to understand some of these issues from a national perspective. So starting today and in the coming weeks, I would urge you to please check your emails for an invitation from us to join this survey. Yours is an important voice that we wish to hear. Hi, I'm Gauri Gopalakrishna, and I'd like to invite you to join me and thousands of my colleagues in the Dutch National Survey on Research Integrity. This survey is a tool to bring about positive change in the way we do research, and I'm joining it because I believe it can strengthen our research community.
I'm joining the Dutch National Survey on Research Integrity because I believe we need to understand the nature and the extent of the problem if we're going to develop solutions.
I'm joining because I'm coaching and mentoring a lot of researchers, and this is still an important topic which has not been discussed out in the open enough.
I'm motivated to decrease misconduct in science, and for this we need empirical evidence of the risk factors that lead to questionable research practices.
I'm joining because I noticed that the pressure to publish conflicts with my ideals on research integrity.
I think it's important to share our experience with research integrity, and not only when it goes wrong.
And with the knowledge that we are going to get out of this survey, we can design tailored interventions that help us create responsible research practices.
I'm joining the survey because I'd like to help out in building better strategies to foster research integrity.
Integrity is the foundation for good scientific research, and it has to do both with ethics and with methodology. So without integrity, no good research.
I'm joining the survey because I believe it can show us where we stand with respect to research integrity in the Netherlands, and it can pave the way towards interventions that will make science even more reliable and relevant.
To achieve this, we need you. Your voice matters. So will you join us? Starting from the 15th of October, check your email.
Thank you, Gauri Gopalakrishna. I got that right this time around. Thank you to everyone who has been with us here this afternoon. I realize it was a long afternoon and we're all in front of our screens way too much, so we're going to end this. Thanks to the organizing team, Gauri, Lex, Sarah, Doreen, many others. Thanks to ZonMW, to NWO, our funders, other partners for making this whole thing financially possible. Thanks to all the speakers today. Thanks to Fenneke for moderating our online audience. And thanks to you again for participating today. This event will be recorded and you can watch it sometime next week on the NSRI website. Let me close with some final thoughts. So we've heard about responsibilities for individual researchers. We've heard about what institutions can do. We've learned a bit about statistics and tools that we can use for research integrity. We heard about qualitative research and how it poses different sorts of challenges. We've learned about replications and problems we might run into when we're trying to publish those studies. We've heard the perspective of funders. Ultimately, what it's all about is making research across different academic disciplines, across all academic disciplines, methodologically sound, sensible to society, relevant to society, and sustainable for individual researchers. So the National Survey on Research Integrity, I truly believe, is going to help us do that. So watch your inbox, make sure you fill out the survey. It's the right thing to do. I'm Jeroen de Ridder. It has been my pleasure hosting this event. I want to wish you all a great afternoon and an even better evening. Thanks for being with us today.